Hello there, and welcome to Life Beyond Seen, where curiosity drifts at an easy pace and science offers a gentle hand instead of a lecture. Tonight, we are not rushing anywhere. Tonight, we're taking a long, slow descent into a part of our world that very few have ever witnessed with their own eyes, though it covers more of the earth than mountains, forests, or deserts. It is the realm far beneath the waves, the place that begins where the last glimmer of sunlight dies. You may know it by its name, the Abyssal Zone, but names only scratch the surface. What lies there is both familiar and utterly alien, comforting in its rhythm and unsettling in its silence. Before we sink into that cold and pressurized world, I'd like to ask you something simple. Where are you listening from right now? Perhaps you're near the coast, where the tide rolls in and out each day, or maybe you're hundreds of miles inland, far from any ocean, with only rivers and lakes nearby. Some of you might even be somewhere without water in sight at all, surrounded by cities or mountains. And yet, wherever you are, the abyss still touches your life. It influences the climate above, the oxygen you breathe, and even the balance of carbon in the air. It may feel distant, but its reach is constant. If you find this kind of exploration calming, a way to let your mind wander while your body relaxes, it would mean a lot if you tapped the like button or subscribed. Not because it changes what we're doing right now, but because it helps more people stumble upon this little corner of quiet curiosity. Sometimes people just need a pause, a calm voice, and a window into something bigger than their everyday schedule. If this gives you that, then your support passes it along. So let's imagine together that we're at the surface of the ocean, maybe sitting in a small boat that rocks gently with the waves. The sun is setting, the horizon blurring into deepening shades of blue and purple, and the air still carries the warmth of the day. Underneath us, though, is another story. The surface hides a layered world that drops away more steeply than the tallest mountain, more vast than any landscape we know on land. We begin our descent slowly. With each meter downward, the light fades. Fish flicker past, silver sides catching what little brightness remains, but they soon vanish into the dark. It's not silence exactly, for the ocean is never truly quiet, but it is a stillness. Fewer sounds, fewer ripples, fewer signs of life as we go deeper. The Abyssal Zone begins about 4 kilometers beneath the surface. That distance is difficult to picture because numbers lose meaning when they get so large. Think of it this way. If you were to stack 10 of the world's tallest skyscrapers one on top of another, you would still not reach the starting edge of this realm. We're talking about a depth where sunlight has no chance of arriving, where the weight of the ocean above pushes with a force equal to thousands of elephants standing on every square meter. Yet, this is not an empty wasteland. It is home. Home to creatures that have adapted to conditions that sound impossible to us. Home to slow processes that shape the planet. Home to mysteries we have only begun to glimpse. As we drift downward in our imagination, the world we leave behind feels almost fragile. Up there, we're used to warmth, light, colour, and sound. Down here, those luxuries disappear. The transition isn't sudden. First, the blue deepens into indigo. Then, the outlines of fish and drifting plankton fade. Soon, it becomes pitch black, a darkness so complete that you can forget the sun even exists. If you've ever closed your eyes and pressed your palms against them, you know the faint bursts of colour your brain invents to fill the void. The ocean gives you none of that. It is darkness that doesn't change, and that can be disorienting to imagine. But it's within that darkness that life continues, resilient and resourceful. The reason we begin here, at the threshold of this zone, is because the abyss has a way of reshaping how we think about life itself. On land, we often imagine living things needing certain basics: light, warmth, air, and yet, in the abyss, organisms thrive without direct sunlight, with temperatures hovering near freezing, and with pressure that would crush human bones instantly. If life can persist there, What does that say about our understanding of survival? What does that say about the boundaries of possibility? These are the kinds of questions that make this quiet journey worth taking. Picture yourself sinking slowly in a submersible, one of those small, thick-walled vessels designed to withstand pressures no human body ever could. The lights outside carve narrow beams through the dark, and for a moment they reveal drifting snow. Not real snow, but what scientists call marine snow, a slow, endless rain of particles that fall from the surface, tiny fragments of dead plankton, bits of fecal matter, remnants of larger animals, all sinking for weeks or months before they reach this depth. For the creatures below, this is food, precious and scarce, the only source of energy aside from the rare, rich communities near hydrothermal vents. Without this steady fall, the abyss would be lifeless. With it, entire ecosystems find ways to survive. It's strange to think that what happens in the open sky above us eventually ends up nourishing life 4 kilometers down. A bird dropping feathers over the sea, a whale shedding skin, a bloom of algae dying after a short season. All of it eventually sinks, and slowly, so slowly, it sustains a world we rarely think about. In this way, the abyssal zone is a reminder of connection, a hidden link between the surface life we know and the unseen communities below. As we descend further, the idea of home becomes more flexible. Up here, we build houses with roofs and doors. Down there, life builds bodies with antifreeze proteins, transparent tissues, and jaws that hinge far wider than seems reasonable. These aren't oddities for them. They are necessities. The abyss does not forgive wastefulness. Every adaptation has a purpose. Every detail is a matter of survival. And when you look closely, the strangeness begins to feel like logic. Of course, a fish should have a mouth large enough to swallow something almost its own size, because food is so rare you cannot afford to let it escape. Of course, many animals glow with their own bioluminescence, because signalling, hunting, or camouflage must be invented anew when sunlight is gone. If you're imagining this and feel a bit unsettled, that's normal. Humans are wired to rely on light and warmth. We find security in things we can see and control. The abyssal zone takes all of that away. It forces us to wonder how anything could be comfortable there. And yet, this is the environment billions of organisms call normal. To them, our bright and dry world would be the strange, hostile one. Let's pause for a moment and think about that pressure again. Imagine a single square the size of your smartphone. At the depth of the abyss, that square would be pressed by the weight of several tons of water. If you took a styrofoam cup down there, it would come back up smaller than your fist, crushed into a dense little shell. Now picture your entire body under that kind of weight. Seems impossible that bones, muscles and organs could endure. That is why we build machines for exploration instead of sending ourselves. But the animals that live there have adapted in remarkable ways. Many have bodies with very little air inside, flexible tissues that do not resist pressure but yield to it. They aren't fighting the weight above them, they've become part of it. As we ease deeper, it helps to remember that human history has only brushed the edges of this environment. Most of the ocean floor remains unmapped. We know more about the surface of the moon than we do about these depths. That isn't just a catchy phrase repeated in documentaries. It's a simple truth of measurement. Satellites can scan the moon without obstruction. The ocean hides itself behind kilometers of shifting, opaque water. Only with specialized vessels, sonar, and occasional daring missions have we glimpsed what is down there. Every time we do, we discover something new, something unexpected. It's like turning the page of a book you thought you knew, only to find a completely new story written inside. And here we are, together, still sinking, still imagining what it would feel like to cross that line into the abyss. Not fast, not rushed, just a slow drift, like falling asleep but with your eyes open. The light above has long disappeared, the sounds have grown fainter, and the water around us is near freezing. This is the threshold. We have reached the beginning of the abyssal zone, where life must adapt or not exist at all. When we talk about the ocean, it's tempting to imagine it as one vast blue space, a single continuous body of water stretching endlessly in every direction. That's what it looks like from above, after all. But once you begin to consider what lies beneath, the picture becomes more complicated. The ocean is not uniform, it is layered, divided into regions that might as well be entirely different worlds. And to understand the abyssal depths, it helps to first recognise the boundaries above them, the hidden architecture of the sea that separates light from darkness, warmth from cold, and abundance from scarcity. The first thing to remember is that the surface is deceptive. When you stand on a beach or look out from a ship, it feels as though you're looking at the ocean in its entirety, but what you actually see is only the skin. This upper layer, sometimes just a few dozen meters thick, is shaped by wind, weather, and sunlight. It is where waves form, where storms churn, and where the sun's energy warms the water enough to allow photosynthesis. Life near the surface is vibrant and busy. Fish dart in schools, plankton bloom in cycles, and seabirds dive for food. It is the ocean most familiar to us because it is the one we touch and interact with directly. Yet even here, there are gradients. The light doesn't penetrate evenly. As you swim deeper, you notice the warmth fading, the brightness thinning, the colours shifting until reds and oranges vanish, leaving only shades of blue and green. Below that first layer is where the structure of the ocean begins to show. Scientists often describe the ocean in zones, not because they are strict boundaries marked by clear lines, but because conditions shift gradually in ways that shape what can live there. These layers are as real as the atmosphere above our heads, and just like with air, the transitions make all the difference. Above, we breathe easily at the surface, but climb a mountain and the air thins. In the same way, swim deeper into the ocean and the light thins, the temperature changes, and the pressure builds. The creatures of the sea have adapted to these layers like climbers on a mountain adapt to altitude, each group belonging to the range where it can survive. The zone closest to the surface is sometimes called the epipelagic, though many simply refer to it as the sunlight zone. It extends down to about 200 meters, a depth where light still reaches strongly enough to power photosynthesis. Here, microscopic algae and plankton thrive, forming the base of the marine food chain. Without them, there would be no fish, no whales, no seabirds circling overhead. Nearly everything we associate with ocean life depends on this narrow band of light. It is no coincidence that most of the world's fishing takes place within it. The sunlight zone is busy, full of movement and colour. Coral reefs, kelp forests, and vast schools of fish belong here, supported by the simple fact that light can still fuel energy at these depths. Beneath it lies the twilight zone, the mesopelagic. This is where the ocean begins to shift into something more mysterious. Light still filters down, but not enough for plants to grow. Instead, creatures here rely on what drifts from above or on their own adaptations for survival. Many of them glow with bioluminescence, producing their own light to lure prey, hide from predators, or find mates. This faint glow is often the only illumination in the water around them, tiny flashes against the darkness. It is a place of contrasts, where life must adapt to both the presence and the absence of light, to scarcity and opportunity, to constant pressure, but not yet crushing weight. Continue further, and you enter the midnight zone, or Bethipelagic. At this depth, sunlight is gone completely. The temperature hovers near freezing, and the pressure increases to levels few organisms on land could endure. The creatures here are stranger still. Long, thin fish with needle-like teeth, jellyfish that drift like ghosts, squid with eyes the size of dinner plates. To us, they appear monstrous, but their forms make perfect sense for their environment. Large eyes catch the faintest hint of light, wide jaws make the most of scarce food, and glowing lures draw meals close in the blackness. The Midnight Zone is vast, covering more of the planet than all forests combined, yet it is a region we know only in fragments, glimpsed through rare expeditions and robotic cameras. And then, past the Midnight Zone, you reach the Abyss. This is where our slow descent has been heading all along, but to arrive here you must first appreciate what comes before. The Abyssal Zone does not stand alone. It is part of a staircase, each step descending into colder, darker, more pressurized realms. The Abyss begins at around 4,000 meters, far beyond the reach of any natural light. Below it lies the Hadal Zone, the deepest trenches of the ocean, where pressure climbs to unimaginable levels. But the Abyss is not just another depth. It is the largest single environment on Earth, covering more of the planet's surface than any forest, desert or grassland. Entire mountain ranges, plains and valleys exist down there, yet they're hidden beneath kilometers of water. To grasp how these layers function, it helps to think of the ocean as a living system, one that circulates and shifts constantly. Warm water rises, cold water sinks, and nutrients cycle between layers. The surface blooms with life when nutrients from below are pulled upward, often by currents or storms. In turn, dead material drifts downward, feeding the twilight and midnight depths. It is a slow, endless exchange. The layers are not isolated compartments. They're connected in a web of movement and dependence. Even so, the differences between them remain stark enough that the creatures of one zone often cannot survive in another. A fish adapted to the Twilight Zone would not last in the Abyss, just as a mountain goat cannot thrive in a rainforest. What makes the layering so profound is that we rarely think of the ocean as structured in this way. On land, layers are obvious. We see mountains rising, valleys falling, forests stretching, deserts spreading. In the ocean, the boundaries are invisible to us. We don't see the gradient of light as it fades. We don't feel the pressure increase as we walk along the shore. To the naked eye, the sea looks flat, featureless. Yet beneath that surface lies a vertical wilderness as varied as any landscape above ground. This hidden structure shapes everything about how life survives there. Take oxygen, for example. Near the surface, photosynthesis produces oxygen, and waves mix it into the water. But in deeper layers, especially in parts of the twilight and midnight zones, oxygen can be scarce. Animals there must adapt to low oxygen levels, often slowing their metabolisms or evolving special hemoglobin to cling tightly to what little oxygen is available. In the Abyss, oxygen levels can be higher again, carried by the slow global circulation of water masses that takes centuries to complete a cycle. These flows link the poles to the equator, the surface to the deep, carrying with them the breath of the planet itself. And then there's temperature. At the surface, water can be warm, sometimes even hot in tropical seas, but descend past the reach of sunlight and the temperature drops quickly, stabilizing near freezing. The Abyssal Zone is consistently cold, hovering around 2 to 3 degrees Celsius. To us, that sounds unbearable, but for the animals adapted to it, the cold is constant, predictable. In fact, one of the defining features of the Abyss is its stability. Unlike the surface, which is shaped by storms, seasons, and daily cycles of light and dark, the Abyss is almost unchanging. Darkness is permanent, temperature nearly fixed, pressure constant. In that stability, life finds its own rhythm. This stability, however, does not mean the Abyss is lifeless or stagnant. Quite the opposite. It is full of motion, but on scales and timescales unfamiliar to us. The slow fall of marine snow, the steady drift of currents, the gradual burial of organic material in the seafloor, all of these shape the deep. Where we think in minutes and hours, the Abyss moves in decades and centuries. Processes that seem imperceptible to us dominate life there, and the layering of the ocean ensures that what happens near the surface eventually influences what happens far below, even if the connection takes years to show itself. Consider what happens when a whale dies at the surface. Its massive body eventually sinks, becoming what scientists call a whale fall. As it drifts downward, it passes through each layer of the ocean, attracting scavengers along the way. When it finally settles on the seafloor, it becomes an island of life in the abyss, feeding entire communities for decades. The layering of the ocean ensures that the nutrients from one giant animal can ripple through ecosystems from top to bottom. Without those layers, the connection would be lost. It's easy to forget that all of this is happening beneath our feet every moment of every day. The surface seems calm, the ocean horizon looks empty, but below it is a vertical expanse of hidden worlds. And somewhere down there, in the abyssal zone, life persists against all odds, shaped by conditions we can barely imagine. To reach it, you must pass through the layers above, each one darker, colder, and more mysterious than the last. Together, they remind us that the ocean is not one thing but many, a collection of worlds stacked upon each other, waiting quietly in the dark. And so, as we continue our descent, we leave behind the familiar surface and the twilight in between. We sink past the midnight depths, and we come at last to the realm where the abyss begins, the place that will be our guide for the rest of this journey. If we keep drifting down through the layers, we find ourselves in a place where the world begins to blur between light and dark. This is the band of ocean that scientists call the twilight zone, though if you were here yourself, twilight might not be the word that comes to mind. The last traces of sunlight filter faintly into the water, no longer bright enough to make shapes clear, but still present as a dim suggestion of above. It is a zone of compromise, where neither light nor darkness fully rules, and the creatures that live here are caught in that balance. The twilight zone stretches from about 200 meters to roughly 1,000. That might sound narrow compared to the vastness of the ocean, but it is enormous when you consider how much space that volume covers across the globe. And it's not just a layer of water, it's a living world with its own unique challenges and solutions. Sunlight here is weak and blue, filtered by the water until it becomes little more than a faint glow. You couldn't read a book in it. You couldn't even see your hand in front of your face after a while. Yet for some organisms, this faint shimmer makes all the difference. Fish here often have eyes larger than seems reasonable, bulging and glossy, designed to catch every trace of available light. Some species, like the hatchetfish, are built almost like mirrors, with bodies covered in reflective scales that help them vanish into the background. If you were a predator looking up from below, their shiny sides would reflect the faint light above, blending them with the dim shimmer of the surface. It is camouflage not by colour but by reflection. Other animals, like lanternfish, glow with bioluminescent organs that they use as counter-shading, producing light on their undersides that matches the glow from above. To a hunter looking upward, they seem invisible, their silhouette erased by their own careful mimicry. It's strange to think of glowing as a form of hiding, but in this zone light is as much a weapon as a shield. Many animals use it to hunt. The anglerfish, one of the Twilight Zone's most iconic residents, dangles a glowing lure in front of its mouth, tricking smaller fish into approaching what looks like food, only to find themselves swallowed instead. Others use bioluminescence to startle predators, flashing suddenly to confuse attackers, or even dropping glowing liquid like a smokescreen while they slip away. There are shrimp that eject clouds of light, jellyfish that produce pulsing glows, and squid that create flashes as if trying to imitate lightning underwater. The Twilight Zone is also a place of vertical travellers. During the day, many animals here sink deeper, hiding from predators in the dark. At night, they rise toward the surface to feed, taking advantage of the cover of darkness to graze on plankton in the upper layers. This daily migration, sometimes called the Deal vertical migration, is the largest movement of life on Earth. Trillions of organisms travel hundreds of meters up and down the water column every single day. It happens so consistently that satellites can detect the faint scattering of their movements. To us it's invisible, but it is one of the fundamental rhythms of the planet. Imagine what it means for a small fish to make this journey. Rising at night means access to food, but it also means risk. The surface is still dangerous, even in darkness, with predators ready to strike. Staying deep during the day means safety, but it also means hunger. And so, they compromise. They risk the climb, feeding under cover of night, then retreating before the light returns. This back and forth, performed on a planetary scale, shows just how much the twilight zone connects the surface to the deep. Nutrients, energy, and biomass are constantly on the move, carried in the bodies of these small but countless travellers. What makes this zone fascinating is not only the adaptations of its inhabitants, but also its role in the Earth's carbon cycle. When plankton near the surface photosynthesize, they capture carbon from the atmosphere. When they die, or when they're eaten and excreted, that carbon sinks. Much of it drifts into the twilight zone, where animals feed on it, transform it, or send it even deeper. This slow conveyor belt of carbon is one of the reasons our climate remains stable. The twilight zone acts as a buffer, pulling greenhouse gases out of the air above by locking them away in the depths below. Without it, our planet would be far less hospitable. So in a way, this dim, shadowy layer of the ocean quietly governs the air we breathe and the climate we live in, without most of us ever realising it. It's also a place that challenges exploration. Submarines and remotely operated vehicles can reach it more easily than the abyss, but visibility is limited and the organisms are fragile. Many deep-sea animals cannot survive the trip to the surface because the change in pressure destroys them, or because their delicate bodies collapse in air. That means our glimpses of them are often fleeting, caught by cameras or preserved only as faint images. What we do know comes from rare expeditions, samples collected with great care, and observations made with technologies that continue to improve. Every time we look, we see something unexpected. A fish with tubular eyes that can rotate inside its head. A jelly with colours that look impossible in the dim light. A squid with arms that stretch far longer than you'd think practical. And yet, despite how strange they appear to us, these creatures belong here. Their designs, however unsettling, are solutions refined by millions of years of evolution. It's not that they chose to be bizarre, it's that their world demanded it. The Twilight Zone is unforgiving and survival requires imagination. That's why so many animals here glow, why so many have oversized eyes, why so many have transparent bodies. It is a realm where ordinary strategies fail, and only the unusual thrives. Think for a moment about sound in this place. Light is weak, but sound travels far in water. Many animals communicate through clicks, pulses, or vibrations. Whales, for instance, send calls that pass through the twilight depths, their voices carrying across ocean basins. Some fish produce noises by grinding teeth or vibrating muscles, a way of signalling without light. In the dim water, sound becomes another sense to rely on, another tool for survival. It is yet another reminder that life finds a way to adapt, whether through vision, chemistry, or acoustics. And then there is the human imagination. The Twilight Zone has long been a source of mystery for sailors and storytellers. Before science reached these depths, people imagined sea serpents, monstrous fish, and creatures large enough to sink ships. When fragments of strange animals washed up on shores, they became evidence of myths, proof of leviathans lurking below. Even today, many of the photographs taken in this zone look more like something from another planet than from Earth. Long, transparent worms, creatures with glowing organs, jaws filled with needle teeth. They all reinforce the sense that we are outsiders here, visitors in a place not designed for us. And yet, it is not hostile. It simply is. The Twilight Zone does not care whether we understand it or not. It functions. It supports life. It connects the surface to the deep. It exists in its quiet balance, unaffected by whether humans pay attention. That is part of its mystery and its beauty. It is humbling to realize that such a vast and vital part of our planet operates out of sight, continuing its rhythms regardless of our presence. As we continue drifting deeper, the faint shimmer of sunlight above finally disappears altogether. The water grows colder, the pressure heavier, the silence more profound. We are leaving behind the twilight compromise, crossing into a realm where darkness is permanent. Ahead of us lies the midnight world, a place stranger still, where light has no natural source, and survival requires adaptations beyond anything we've seen so far. As the last traces of sunlight vanish above, we find ourselves crossing into a world where darkness is no longer a passing condition, but a permanent state. Here, in the midnight depths of the ocean, day and night are meaningless words. The sun could flare brilliantly at noon, the moon could shine in a cloudless sky, but none of that light penetrates this far. Once you enter this place, you have left behind the surface world completely. This is an environment where darkness has weight, pressing in from all sides, and where life has adjusted to a reality that would feel impossible to us. The midnight zone begins around 1,000 meters below the surface and extends down to nearly 4,000. To put that in perspective, if you lowered Mount Everest into the sea, its peak would still fall short of this region. It is not just deep, it is unimaginably vast, stretching across every ocean basin on Earth. And within it live creatures that seem to bend the rules of biology, animals that have evolved to survive without sunlight, under crushing pressure, in temperatures that hover just above freezing. For a moment, picture yourself in a submersible sinking into this darkness. The walls around you creak faintly under the pressure, but the glass bubble in front of you holds steady, revealing a scene unlike anything you've experienced. The beam of your light stretches out only so far before fading into black. Occasionally shapes drift into view. Jellyfish pulsing slowly, a fish with a mouth that seems too wide for its body, a squid with arms that trail like ribbons. Then, just as suddenly, the lights reveal nothing at all, only drifting particles and emptiness. This is not emptiness in the true sense, of course, but the sensation of being surrounded by vast space where life is sparse and scattered. Despite the apparent emptiness, this zone is far from lifeless. It is home to countless species, most of which we have never seen. The midnight depths contain some of the strangest adaptations in the natural world. Consider the gulper eel. Its body is long and slender, but its mouth is disproportionately huge, capable of opening wide enough to swallow prey nearly as large as itself. Why evolve such an oversized mouth? Because food here is unpredictable. A fish might drift past once in a week, and if it is larger than you, letting it go means starvation. Better to have a mouth that looks absurd than to miss a meal. Then there is the anglerfish, famous for the glowing lure that dangles from its forehead like a fishing rod. In the darkness, that lure shines faintly, a beacon for smaller fish who mistake it for food or safety. They approach, curious, only to be engulfed by teeth so sharp and fine they interlock like the bars of a cage. What's more, in many species of anglerfish, the females dwarf the males. Males are so small and underdeveloped that their sole purpose is to attach themselves to a female's body, fusing with her until they become little more than a permanent source of sperm. It sounds grotesque, but in an environment where finding a mate is almost impossible, it is an efficient solution. Many creatures of this zone use light not just for hunting, but for survival itself. Bioluminescence is everywhere here, a kind of language that has evolved again and again in different lineages. Some animals flash to startle predators, others pulse rhythmically to signal potential mates, and still others glow steadily to lure prey. In a place without sunlight, light becomes a currency, a tool, and in some ways the only form of communication. Imagine drifting in darkness, unable to see more than a few meters, and suddenly a series of glowing dots passes by in perfect sequence. To you, it looks like a constellation drifting through the water. To another fish, it might be the signature of a mate. To a predator, it might be a warning to stay away. It's not only the biology of these creatures that fascinates, but also the physics of their world. Pressure here is immense, hundreds of times greater than at the surface. If you tried to dive unaided, your lungs would collapse instantly, your body would be crushed. Yet the animals here are not simply surviving the pressure, they are thriving in it. Their bodies are built differently, often lacking the air-filled cavities that cause problems for surface dwellers. Instead, their tissues are flexible, their cells adapted to resist crushing. Some produce special proteins that keep their enzymes working under pressure, preventing them from folding in ways that would shut down metabolism. It is survival not through resistance but through surrender, by yielding to the environment rather than fighting it. And still, for all its extremes, the Midnight Zone has a kind of stillness. There are no storms here, no seasons, no cycles of day and night. The temperature remains steady, the darkness constant. To us, that constancy might feel monotonous, even oppressive, but for the creatures here, it is a foundation. Their lives are not marked by the rising and setting of the sun, but by the slow drift of food from above, by the occasional arrival of a whale fall, or by the rare encounter with another of their kind. Time moves differently in a world where change is rare and survival depends on patience. Even here, the vertical migration that begins in the Twilight Zone continues. Lanternfish, bristlemouths, and other small creatures rise at night to feed near the surface, then sink back into the midnight depths by day. This movement, repeated by countless individuals across the planet, transports energy and nutrients between layers of the ocean. In doing so, it ties the Midnight Zone to the surface above and the abyss below. It is a reminder that no part of the ocean truly exists in isolation. Even in the darkest depths there are connections, cycles and flows that link one world to another. Exploration of this zone has been limited, but what we have seen challenges our assumptions. In 2014, scientists recorded footage of a giant squid alive in the deep sea, its arms stretching long and its body glowing faintly in the artificial light. For centuries, the giant squid was a creature of legend, thought to be nothing more than sailors' stories about krakens pulling ships into the depths. Yet here it was, real and alive, not a monster, but an animal, perfectly adapted to its world. Encounters like this remind us how much of the Midnight Zone remains hidden. For every species we discover, there are likely hundreds we have never seen, living out their lives in darkness, unaffected by our curiosity. The Midnight Zone also holds significance for the planet itself. As animals feed and excrete, as carcasses sink and decompose, carbon is carried downward. Much of it is consumed here, transformed and recycled, slowing the return of carbon to the surface. This process, often called the biological pump, plays a crucial role in regulating the Earth's climate. Without it, far more carbon would remain in the atmosphere, warming the planet. In this way, the silent work of countless small organisms in the midnight depths helps shape the conditions on land, influencing everything from weather to agriculture. It is one of those hidden systems that sustain life without most of us ever realizing it. To imagine yourself here for longer than a few minutes is unsettling. The human body craves light and warmth, cues that regulate our sense of time and space. In this darkness, those cues vanish. Minutes might feel like hours, or hours like minutes. The cold would seep in quickly, and the silence would feel oppressive. But the animals here are not unsettled. To them, this is not a place of deprivation, but of balance. The darkness is protection, the pressure is stability, the cold is consistency. Where we see harshness, they see home. And so, drifting deeper, we leave the twilight compromises behind and embrace a world of permanent night. We pass through water that grows denser and colder, through layers where familiar creatures no longer appear. Ahead of us lies the beginning of the Abyssal Zone, the realm where darkness, pressure, and cold become more than challenges. They become the defining rules of life. What awaits us there is stranger still, an environment so vast and so stable that it may be the most important ecosystem on Earth, even though most of us will never see it. By the time we reach the realm scientists call the Abyss, we have already left behind every trace of sunlight, crossed through twilight compromises, and passed into the permanence of night. Yet this next layer is not simply a continuation of the Midnight Zone. It is something larger, more extreme, and more stable than anything above it. To say abyss is to invoke an idea of endlessness, of unfathomable depth. The word itself comes from ancient Greek, meaning bottomless. Of course, in a literal sense, the ocean has a bottom, but when people first imagined the abyss, they weren't thinking in measurements. They were thinking in feelings. To gaze into waters this deep is to face something vast enough to seem without limit. And in many ways the name still fits. The Abyssal Zone stretches from around 4,000 metres down to 6,000, covering an area so enormous that it makes up more than half of the Earth's surface. When we picture ecosystems on our planet, we tend to think of rainforests, grasslands, tundras, deserts. But none of those come close in scale to the abyss. It is the single largest environment for life on Earth, yet it is also the least visible, hidden beneath kilometres of water. That paradox, vastness paired with invisibility, shapes everything about how we understand it. To stand on land and think about 4 to 6 kilometres does not sound impossible. We walk such distances easily in an afternoon, but when those kilometres are vertical and filled with dense cold seawater, the numbers take on a new meaning. The weight of the ocean above presses down with a force that is difficult to imagine. At the top of the abyss, every square inch of a body is under pressure equal to thousands of pounds. At the bottom, the pressure grows even greater. And unlike mountains, where climbers can pause and adjust as they ascend, the abyss offers no such breaks. The conditions here are unchanging, relentless, and permanent. One of the most striking things about this zone is its stability. While surface waters are in constant flux, storms, tides, temperature shifts, the abyss is almost monotonous. The temperature remains close to 2 or 3 degrees Celsius, year after year, century after century. Light never changes. There is no sunrise, no sunset, no seasonal shift. Pressure does not fluctuate. In this consistency, life has found a way not just to endure, but to thrive. Creatures here are specialists in stability, adapted to a world where the rules do not shift. But what does it mean to be abyssal in the biological sense? It means to belong to this enormous layer of Earth where energy is scarce, where food is unpredictable, and where the environment demands efficiency above all else. Most abyssal creatures move slowly, conserving energy. Many are scavengers, relying on whatever drifts down from the surface. Others are ambush predators, lying in wait for the rare opportunity when prey wanders near. Growth is slow, reproduction is often infrequent. Life here is not about abundance or speed, but about persistence. Consider the abyssal plain, the vast seafloor that stretches across much of this zone. Unlike the jagged mountains or steep cliffs of land, the abyssal plain is flat, featureless, and enormous. It is covered in fine sediment, the accumulation of particles that have been drifting down for thousands of years. At first glance it looks barren, like a desert of mud, but look closer and you find it teeming with strange life. Sea cucumbers crawl across the surface, filtering organic matter from the sediment. Starfish spread slowly, their arms tracing deliberate paths across the floor. Worms, crustaceans, and countless microbes live in and beneath the mud, forming a hidden foundation for the food web above. The abyssal plain is punctuated by features that break the monotony. Seamounts rise like undersea mountains, ridges stretch for thousands of kilometres, and trenches mark the transition to even deeper zones. Hydrothermal vents spew mineral-rich water, creating oases where life flourishes in abundance. But most of the abyss is quiet, flat and uniform. That uniformity makes it one of the most alien landscapes on Earth. To visit it in person is to confront a world without landmarks, without variation, stretching beyond sight in every direction. For the animals that live here, adaptation means finding ways to survive on little. The marine snow that falls from above, tiny particles of dead plankton, feces and organic debris, provides the main source of food. Occasionally a larger feast arrives, such as the carcass of a whale, sinking slowly over weeks until it reaches the bottom. These whalefalls transform the seafloor into a hub of activity, feeding scavengers and decomposers for decades. Crabs, worms, fish, and bacteria gather to strip the carcass, layer by layer, until even the bones are consumed by microbes. In the abyss, nothing is wasted. Every scrap of energy matters. It is tempting to think of the abyss as empty, but that emptiness is deceptive. Because it is so stable, life here is both widespread and continuous. Populations may be sparse compared to the surface, but they extend across the globe. Some species of deep-sea fish are thought to be the most numerous vertebrates on the planet, existing in numbers that dwarf the combined populations of birds and mammals on land. We rarely see them, yet they are among the dominant life forms of Earth. That fact alone reshapes how we should think about the planet. The world we know is not defined only by what we can see, but by what thrives beyond our perception. To be abyssal also means to be part of a system that functions on timescales far slower than we are used to. Sediment builds at the rate of millimeters per century. Populations may remain stable for thousands of years. Energy cycles take decades to complete. When we measure change in the abyss, we often need to think in terms of centuries rather than seasons. For us, used to daily news cycles and yearly calendars, that slowness is difficult to comprehend. But it is the rhythm of the deep. The abyss does not hurry. Another way to think about what abyssal means is to look at how humans have interacted with it. For most of history, the abyss was a mystery. Sailors could imagine monsters and endless depths, but they had no way to confirm what lay below. The first real glimpses came only in the 19th century, when expeditions like the voyage of the HMS Challenger began dredging the seafloor. What they found surprised them. Life at depths once thought impossible. Starfish, shrimp, fish, and countless other organisms were pulled from nets lowered miles into the water. The idea that life could exist without sunlight challenged old assumptions. Since then, technology has given us better access, but even today, the abyss remains largely unexplored. Submersibles and remotely operated vehicles can visit, but only briefly. The cost and difficulty of reaching such depths means that most of the abyssal zone has never been seen by human eyes. When we do visit, we're often startled by what we find. Fish with translucent bodies, gelatinous creatures that drift like ghosts, communities clustered around vents that thrive without sunlight. Every expedition reveals something new, reinforcing the sense that the abyss is not just vast but also endlessly surprising. This raises another meaning of the word abyssal, not just a description of a zone, but of an experience. To look into the abyss is to feel small, to realise that our familiar world is only one layer of the planet, and not even the largest one. It is to confront the limits of our understanding, to acknowledge that most of life's diversity exists out of sight. The abyss forces humility, reminding us that our everyday perspective is partial and incomplete. Yet, despite its strangeness, the abyss is not disconnected from us. It plays a crucial role in regulating the Earth's climate. It stores vast amounts of carbon, cycles nutrients, and shapes the chemistry of the oceans. Without it, the surface world we know would not function as it does. Our weather, our oxygen, our food supplies, all are influenced by processes that take place in the abyss. Even as we live our daily lives far above, this hidden zone is working quietly to sustain us. So what does abyssal really mean? It means vastness. It means stability. It means survival under conditions that seem impossible. It means hidden systems that shape the surface world without recognition. It means a place where time slows, where change is measured in centuries, and where life has adapted to thrive on scarcity. It means a reminder that our planet is stranger and more complex than the part we see. And as we drift deeper still, past the upper edge of this realm, we begin to feel the weight of what lies above us in a more literal sense. The pressure builds with every meter, shaping everything in this zone, forcing life to adapt in ways that look bizarre to us but make perfect sense here. Ahead of us lies the true experience of that weight, the reality of a world defined by pressure, where every living thing must respond to forces far beyond what we can endure. When we imagine the sea, we usually picture its surface, the glitter of sunlight, the roll of waves, maybe the rhythm of tides sweeping in and out. But as we sink into the abyss, what really defines this world is not the light above, but the sheer weight pressing down from it. Every drop of water carries mass, and as those drops accumulate kilometre upon kilometre, they build into a pressure so extreme it is difficult to grasp. To understand what life endures here, you need to think not in terms of what you see on land, but in terms of forces that never let up. An invisible weight that shapes every living thing in the abyssal zone. At the surface, the pressure of the atmosphere around us is about 1 bar, or 1 atmosphere. We don't notice it because our bodies are built to match it. But with every 10 metres you descend in the ocean, pressure increases by another atmosphere. That means at just 100 metres, divers already feel about 10 times the pressure of the air we live in. At 1,000 metres, it is 100 times greater. And here, in the abyssal zone between 4,000 and 6,000 metres, the pressure reaches hundreds of times what we experience on land. Imagine the weight of a car pressing down on a single fingernail. That is roughly the kind of force animals here endure constantly, not as a sudden crush, but as the background condition of their lives. Humans cannot survive this unaided. Our lungs, filled with air, would collapse. The spaces in our bodies that hold gas, sinuses, ears, even the tiny cavities in our bones, would implode. For us, this environment is lethal, but for the animals that live here, it is not even uncomfortable. They have evolved in such a way that pressure is not a problem to be solved, but a fact of life to be accepted. Many abyssal creatures lack air-filled spaces altogether. Their bodies are soft, gelatinous and flexible, so instead of resisting the pressure, they yield to it. There is nothing inside to collapse. Their tissues are made of water-rich compounds that balance with the water around them. Where our bodies would break, theirs simply continue, unbothered by the force pressing in from all sides. Some fish in these depths produce unique proteins that keep their enzymes working under pressure. At surface levels, proteins in our cells fold neatly, carrying out chemical reactions that sustain life. But under abyssal pressure, those proteins would distort, shutting down metabolism. Abyssal creatures have adapted with molecules called piezoletes, which act as stabilizers, preventing enzymes from folding incorrectly. It is a microscopic adjustment, but it is the difference between collapse and survival. It shows that life here is not only about enduring weight physically, but about reworking biology at the molecular level. Pressure also influences behaviour and structure in ways that seem strange to us. Many abyssal animals move slowly, conserving energy in an environment where food is scarce, and where high-pressure conditions make activity costly. Their bodies are often elongated or gelatinous, their muscles less dense than those of surface animals. To us, this looks weak or fragile, but in reality it is efficient. To move quickly here is unnecessary. To be soft is not a disadvantage, but a design that fits the environment. Pressure rewards creatures that do not fight it, that allow themselves to exist within its rules rather than against them. Imagine being in a submersible at this depth. The walls of the vessel are made of thick metal or specially engineered composites, curved into a sphere to distribute stress evenly. Engineers know that even the smallest weakness, a hairline crack or a poorly designed joint, could spell disaster. The pressure would find that flaw instantly and exploit it, crushing the vessel in a heartbeat. This is why exploring the abyss is so difficult and expensive. It requires technology that can withstand what no human body can. And yet, while we struggle to survive here with all our machinery, the fish and invertebrates outside swim gracefully, unbothered, as if the crushing force does not exist at all. For them, the weight is not something to fear, but simply the way the world is. When you think about it, that perspective challenges how we view harsh environments. What seems extreme to us is normal for them. The weight of the world above is not an obstacle, but a constant companion. It shapes their bodies, their chemistry, their strategies for life, and in a way, it defines the very idea of the abyss. Without this immense pressure, the zone would not be what it is. Its creatures would not look as they do, nor would they have evolved the peculiar adaptations that fascinate us. Pressure also plays a role in shaping the geology of the abyss. The seafloor here is covered in fine sediment, laid down slowly over millions of years, compacted by the water above. Mountains rise more slowly, volcanoes erupt differently, and tectonic movements happen under constraints that surface geology never experiences. Even the chemistry of the water is influenced by pressure, altering how gases dissolve and how minerals behave. The abyss is not just a biological world, but a physical one remade by the sheer weight of its environment. One striking example of adaptation to pressure is found in the snailfish, some of which live deeper than 8,000 meters, even beyond the abyss into the Hadal trenches. These fish have translucent bodies with no scales, soft bones, and flexible cartilage. Their organs are supported not by rigid skeletons, but by the surrounding water itself. In the absence of light, they rely on touch, and perhaps chemical cues more than vision. Scientists studying them have discovered that their enzymes contain unusually high concentrations of piezolates, which help their cells continue working under extreme compression. To look at a snailfish, you might think it delicate, even fragile, but in truth it is one of the most pressure-resistant animals on the planet. And then there are the microbes. For every fish or shrimp we marvel at, there are countless bacteria and archaea thriving in the sediments of the abyssal plain. Some of them have adapted so completely to high pressure that they cannot survive at surface levels. Bring them up, and they die, not from lack of food or oxygen, but because the absence of crushing force destabilizes their cellular machinery. To them, our world is just as hostile as theirs is to us. It is a reminder that normal is always relative. This endless pressure also affects reproduction. Many abyssal creatures grow slowly, taking years to reach maturity. They produce fewer offspring than their surface counterparts, but each offspring is better equipped to survive in scarcity. Some species release eggs or larvae that drift upward into shallower waters, developing where conditions are less severe before sinking back down as adults. Others reproduce directly in the deep, their young born into darkness and wait from the very start. In both strategies, the influence of pressure is clear. It is not just a background condition. It is the architect of life cycles deciding what works and what fails. There is also a psychological dimension when humans confront this weight, even from the safety of a vessel. Astronauts describe the emptiness of space as awe-inspiring, but in space there is nothing pressing against you. In the abyss there is always the knowledge of what lies outside, tons upon tons of water pressing on every square centimetre. That awareness creates tension, even in trained explorers. For animals here, there is no such tension. They are born into it, shaped by it, unaware that another world even exists. The weight of the ocean above is not only a force, but a filter. It decides which organisms can survive and which cannot. It has sculpted life into forms we see as alien, but which are perfectly logical in this environment. It determines what kinds of ecosystems can exist, what kinds of behaviours make sense, and even what kinds of materials can endure. Without it, the abyss would not be alien at all. With it, it becomes one of the most extraordinary realms on the planet. As we continue to drift through this pressurized silence, the presence of the surface world feels more distant. The sun, the air, the shifting winds, they are no longer relevant here. What matters now is stability, pressure, and the adaptations that allow life to not only survive but to become abundant under those conditions. Ahead, the next defining feature of the abyss awaits: the cold, a chill so constant and so deep that it is inseparable from this realm. Just as pressure defines the structure of life here, so too does the freezing temperature, setting the rhythm for everything that survives in the darkness. Here in the depths of the abyss, after pressure has already claimed the role of constant companion, another condition defines existence just as firmly. It is the cold, not the shifting kind we know on the surface, where seasons alter temperatures by tens of degrees, but a steady, near-freezing chill that never lifts. This cold is not a passing discomfort or a fleeting challenge. It is the permanent backdrop of life in the abyss, shaping biology, chemistry and rhythm with a grip that is absolute. The ocean, from surface to abyss, carries temperature like a signature. Warmth at the surface comes from the sun, absorbed in waves and spread by winds and currents. But sunlight fades quickly with depth, and so does heat. By the time you reach the upper twilight zone, the water is already cool. Pass through the midnight depths, and it stabilizes near freezing. In the abyssal zone, temperature hovers around 2 to 3 degrees Celsius, seldom changing even over centuries. Imagine the coldest winter morning you've stepped into on land, the kind where your breath hangs visibly in the air and your hands ache within minutes. Now imagine that cold not as a fleeting weather event, but as the permanent condition of your entire world. That is what the creatures of the abyss endure every moment of their lives. But what makes this cold remarkable is not simply its presence, but its consistency. On land, ecosystems are defined by fluctuations: heat in the day, cold at night, seasons shifting year to year. Animals and plants adapt to cycles. In the abyss, there are no cycles. There is no day to warm and no night to cool. The cold is as unchanging as the darkness. For life, this constancy means that survival is not about enduring extremes, but about aligning completely with one state. Bodies evolved not for flexibility, but for precision, tuned to thrive within a narrow, unvarying range. It might seem impossible for living cells to function at such low temperatures, where chemical reactions slow dramatically. Yet, again, life has found ways. Many abyssal creatures produce antifreeze proteins in their tissues, preventing ice crystals from forming inside their cells. Even though the water here does not quite freeze, being rich in salts that lower its freezing point, the margin is thin. Without these adaptations, the risk of crystallization would remain. With them, the cold is not fatal but simply a fact of life. Metabolism slows in the cold, and this has consequences for everything from growth to reproduction. Abyssal fish grow more slowly than their shallow water relatives. They live longer, sometimes by decades, moving deliberately and conserving energy. Some deep-sea invertebrates may live for centuries, their lifespans stretched out by the reduced pace of life. It is as if the cold itself stretches time, extending life not by increasing energy, but by slowing its consumption. What feels like scarcity to us is a form of balance here. When food arrives in small amounts, it is enough, because bodies built for the cold burn so little of it. This slowness can be seen in reproduction as well. Many abyssal animals produce fewer offspring, but invest more energy in each. Instead of relying on constant reproduction to ensure survival, they bet on quality over quantity. A single offspring well equipped to handle scarcity and cold may be more valuable than hundreds that cannot endure. For species that do produce large numbers, the young often rise to shallower waters where conditions are slightly warmer, developing there before returning to the depths. This balance between environments is another reminder that even in the abyss, connections to the surface remain. One of the most extraordinary examples of adaptation to the cold can be found in the microbial world. Abyssal bacteria and archaea are able to carry out chemical reactions that would normally stall at such temperatures. Their enzymes are specially shaped to remain flexible even in near-freezing water, preventing the sluggishness that surface-dwelling microbes would suffer. Some of these microbes play vital roles in recycling nutrients, breaking down organic matter that drifts from above. Without them, the abyss would accumulate dead material without ever transforming it. Instead, they keep the ecosystem moving, turning decay into the building blocks of new life. The cold also influences how energy is distributed. In warmer waters, organisms can afford to move quickly, to chase prey, to live fast lives. In the abyss, that strategy fails. A predator that expends too much energy in pursuit may not find another meal for weeks. Instead, the cold encourages patience. Hunters here often sit and wait, conserving energy until the rare chance arises. Prey animals, too, are deliberate. Sudden bursts of speed are rare. Movements are often slow, drifting, almost ghostly. It is a kind of economy, dictated not by choice but by necessity. And yet, the cold does not mean lifelessness. Quite the opposite. In certain places where the abyss meets hydrothermal vents or cold seeps, life flourishes in abundance. At vents, superheated water from beneath the seafloor pours into the freezing ocean, creating sharp temperature contrasts. Bacteria thrive in these extremes, using chemicals instead of sunlight to fuel growth, and larger animals gather to feed on them. Tube worms, clams, crabs, and fish cluster around vents in communities that defy the emptiness of the surrounding plain. Here, the cold defines the background, but the sudden heat of vents provides bursts of energy, creating pockets of life as rich as coral reefs. Even outside these oases, the abyss supports life across its expanse. The seafloor is littered with traces of creatures adapted to the cold, from brittle stars to sea cucumbers. Fish with antifreeze proteins glide slowly through the water, jellyfish drift without effort, and squid pulse faintly with bioluminescent light. None of them look like the animals we know from the surface, and yet each is a solution to the same question. How do you survive in a world that never warms? The consistency of the abyssal cold has another effect, one that reaches far beyond the seafloor. It drives the circulation of the entire ocean. At the poles, cold, dense water sinks, beginning a journey that moves around the globe, a conveyor belt of currents that can take centuries to complete a loop. This movement redistributes heat, oxygen, and nutrients, linking the surface with the deep. The abyss is not just shaped by cold, it helps shape the climate of the entire planet. Without this circulation, weather on land would change dramatically, and many ecosystems above the sea would collapse. It's worth considering how humans react to this kind of environment. Cold on land is often seen as hostile, something to be endured or escaped. We wrap ourselves in coats, light fires, build heated shelters. In the abyss, none of those options exist. The animals here do not resist the cold but accept it completely, building their biology around it. For us, the idea of living in water only a few degrees above freezing feels impossible. For them, it is simply the baseline. Once again, the lesson of the abyss is that harshness is a matter of perspective. What feels like limitation to us is a foundation to them. This constant cold also preserves. Objects that sink into the abyss often remain intact for decades or centuries. Wooden debris from ships, whale bones, even human artifacts can linger on the seafloor far longer than they would in warmer, more active environments. Microbial decomposition is slower, scavengers move at a reduced pace, and the sediment covers objects gently. In a way, the abyss is a vast archive, storing the history of what has fallen into it. The cold does not erase, it conserves, and perhaps that is the most striking part of the abyssal chill. It is not only a force of limitation, slowing metabolism and reducing energy, it is also a force of endurance, extending lifespans, preserving remains, and stabilizing systems. In the stillness of near-freezing water, life takes on different rhythms, slower but often longer-lasting. If the surface is a world of urgency, the abyss is a world of patience. As we continue drifting here, surrounded by water that never warms, the next defining question arises. If light is gone, if warmth is gone, how can life continue? The answer lies in something else entirely, in the ability of organisms to make their own light, to turn darkness into advantage, and to transform the absence of sunlight into a new kind of resource. Ahead of us lies a world where glowing bodies drift like stars, where communication and survival depend on producing light from within. Here, at depths where sunlight has never reached, the question of how life persists becomes more pressing. On the surface, the energy of the sun fuels nearly everything. Plants capture light, convert it to sugars, and pass that energy upward through food chains. Even the meat-eaters among us depend on it indirectly, because the animals they consume depend on plants, and the cycle goes on. Remove the sun from that equation, and most of the life we recognize collapses. So what happens when you sink past the last photon of daylight? What happens in a world where photosynthesis is impossible, where the very basis of energy at the surface ceases to exist? That is the condition of the abyss, and yet life not only endures here, it thrives in forms that defy surface expectations. The most obvious strategy is reliance on what falls from above. Every living thing at the surface, from the smallest plankton to the largest whale, eventually becomes part of the rain that descends through the water column. Dead plankton sink as tiny flakes, fish release waste, jellyfish bodies drift downward, and even fragments of plants from coastal waters can find their way into the deep. Collectively, this is called marine snow, and it is the lifeblood of the abyss. It drifts constantly, though slowly, sometimes taking weeks to travel from the surface to the sea floor. To us, it looks like dust in a beam of light. To the creatures below, it is food, precious and scarce. When you imagine this snowfall, it's important to realize how thinly it spreads. By the time particles drift to abyssal depths, most of their energy has already been consumed in the layers above. What arrives is diluted, meagre compared to what began at the surface. For that reason, abyssal animals have evolved to survive on very little. Sea cucumbers crawl slowly over sediment, sifting through grains to extract organic material too small for us to see. Brittle stars extend arms across the seafloor, catching fragments as they fall. Small fish and crustaceans hover in the water, picking off flakes of snow before they touch down. Every particle matters, and nothing is wasted. Occasionally, something larger arrives. A whale fall, for example, can transform the abyss. When a whale dies at the surface and its body sinks, it brings with it an enormous store of energy. For decades, entire communities can live off a single carcass. At first, scavengers like hagfish and sleeper sharks strip the soft tissue. Then, as the years pass, worms and microbes colonize the bones themselves, breaking them down and releasing nutrients. Each stage of decomposition supports new waves of life. In an environment where food is rare, the arrival of a whale is like the sudden growth of a forest in a desert. It doesn't happen often, but when it does, it leaves a mark that can last for generations. And yet, marine snow and whale falls are only part of the story. Perhaps the most extraordinary discovery about life without sunlight came when scientists first explored hydrothermal vents in the late 1970s. These vents, scattered along tectonic boundaries on the seafloor, release superheated water rich in minerals. To the surprise of everyone, researchers found thriving ecosystems clustered around them. Tube worms meters long, giant clams, crabs, shrimp and fish. These animals were not feeding on marine snow. Instead, They were sustained by bacteria that use chemicals from the vents as fuel. This process, called chemosynthesis, is the deep sea's equivalent of photosynthesis. Instead of capturing sunlight, these microbes capture energy from hydrogen sulfide and other compounds. They form the base of food webs entirely independent of the surface. Think about what that means. Entire ecosystems, dense with life, operating without any connection to the sun. In these communities, bacteria live inside the tissues of tube worms, providing them with nutrients directly. Clams filter water rich in microbes. Crabs and fish graze or hunt among the colonies. In some vent fields, the biomass rivals that of tropical reefs, all in a place where the water around is near freezing and the pressure immense. This discovery reshaped our understanding of what is possible. If life can thrive here, using chemistry instead of sunlight, then perhaps it can exist in other dark places as well, under the icy crust of Europa, or in the methane seas of Titan. The abyss shows us that life's foundation is not limited to light. But not all abyssal life lives near vents. For the vast expanses of the plain, where no vents break the monotony, survival depends on efficiency. Many fish have bodies adapted for energy conservation. Their muscles are flabby compared to surface species, reducing metabolic demands. Their jaws often hinge wide, allowing them to eat prey nearly their own size. If food is scarce, it makes sense to eat whatever you can, whenever you can, even if it looks absurd. Other creatures are transparent, reducing the energy cost of producing pigments. Some are nearly motionless for long periods, waiting until food drifts close enough to catch without wasting effort. Every adaptation reflects the same principle. In a world without sunlight, nothing is easy, and every advantage is precious. Reproduction in this realm often shows similar adaptations. Some species release eggs that float upward, giving larvae a chance to develop in waters where food is more abundant, before returning to the deep as adults. Others rely on strategies that maximize the chance of fertilization in a world where encounters with mates are rare. The parasitic males of anglerfish are a famous example. A male, once he finds a female, attaches permanently to her body, fusing his tissues until he becomes a part of her. To us this sounds grotesque, but in the abyss, where distances are vast and populations sparse, it is a reliable solution. Even in the absence of sunlight there is light here, but it is made by the creatures themselves. Bioluminescence is not rare in the abyss, it is nearly universal. Fish, jellyfish, squid, shrimp, even some bacteria glow. They use light to lure prey, to attract mates, to confuse predators, or to camouflage themselves. Some produce steady glows, others flash in patterns, and still others release glowing clouds that drift through the water like liquid fire. This is the language of survival in a world without sunlight. Light is no longer given freely by the sun, so organisms have evolved to generate it from within. The diversity of these strategies shows us something profound. Life is not dependent on any one condition. It is flexible, inventive, and resourceful. When deprived of sunlight, it finds alternatives. When cut off from warmth, it endures the cold. When crushed by pressure, it adapts at the molecular level. The abyss is not barren, as people once assumed. It is rich with evidence that life's boundaries are far wider than we imagined. And yet, the absence of sunlight does define this world in fundamental ways. Without photosynthesis, the flow of energy is far thinner, slower, and more fragile. A bloom of plankton at the surface might take weeks to influence the abyss below, its remnants drifting downward bit by bit. A whale fall may sustain a patch of seafloor for decades, but once it is gone, the community must disperse or adapt. Even vent ecosystems, rich as they are, can vanish when a vent shuts down, forcing organisms to find new sites or die. In the abyss, life is not constant abundance, but constant adaptation. From a human perspective, this absence of sunlight makes the abyss feel otherworldly. Our senses are built around light. We navigate by it, measure time with it, and depend on it for our food. To imagine living without it requires letting go of instincts we rarely question. That is perhaps why the abyss has so often been a setting for myth and fear. Darkness suggests danger, the unknown, the possibility of monsters. But for the creatures here, darkness is not frightening. It is the normal state. To them, a world filled with light would be just as strange and unsettling as their darkness is to us. As we sink further into this realm, it becomes clear that sunlight is not the only way to sustain life. In the deep, energy can come from snow drifting down, from whales sinking slowly, from chemicals rising at vents, from microbes recycling decay, from bodies producing their own glow. Each of these strategies is a response to the same condition, the absence of the star that fuels everything above, and in their diversity they remind us that life is not fragile, it is inventive. Ahead of us, as we continue into the abyssal dark, the faint glows of bioluminescent creatures become more common, tiny sparks scattered in the black. If sunlight cannot reach, life will make its own stars. The abyssal zone is not just a place without light, it is a place where light has been reinvented, turned into a tool that belongs not to the sun, but to the animals themselves. In the abyss, where sunlight is gone forever, the darkness is not total. Instead, it is scattered with brief sparks, steady glimmers, and sudden bursts of living light. These are not illusions. They are not tricks of the eyes. They are organisms themselves, producing light within their own bodies. If you were sitting in a submersible and turned off its lamps, you would not see black emptiness forever. You would see small, glowing signals drifting past like stars on a windless night. Some steady and faint, some pulsing like distant lighthouses, some flaring suddenly as though a firework had gone off, only to fade a second later. The creatures of the abyss have transformed darkness into an opportunity, and light into a survival tool. Bioluminescence, the ability to produce light biologically, is one of the most widespread adaptations in the deep sea. Scientists estimate that the majority of organisms below 1,000 meters possess some form of it. Fish, squid, shrimp, jellyfish, worms, even microbes. Across all these groups, light has evolved again and again. What is striking is not just how common it is, but how many different purposes it serves. Light here is communication, camouflage, weapon, distraction, lure, and sometimes all of these at once. In a place where no external light source exists, it is one of the only ways to interact with the environment beyond touch and sound. One of the most well-known examples is the anglerfish. Its lure, a modified fin ray tipped with a glowing organ, dangles in front of its mouth like bait on a fishing rod. In the eternal night of the abyss, smaller fish are drawn to this glow, mistaking it for food or for the bioluminescence of other prey. When they approach, the anglerfish opens its enormous jaws, and in an instant, the glow becomes the last thing the victim ever sees. It is a strategy of deception, turning light into a trap. Other animals use bioluminescence not to hunt, but to hide. The hatchetfish, for example, has rows of light-producing organs along its underside. When viewed from below, its body would normally appear as a dark silhouette against the faint glow from above. But by adjusting the brightness of its lights to match the surrounding shimmer, it erases its outline. To a predator looking up, it vanishes. This is counter-illumination, a camouflage technique perfected in a world where shadows mean death. Then there are shrimp and squid that use light to startle or distract. Some species release glowing chemicals into the water, creating a cloud of brightness that lingers while they dart away unseen. Others flash suddenly, hoping to confuse an attacker long enough to escape. In some cases, the bursts of light are so intense that they resemble miniature explosions in the water. To us, it looks dramatic, almost theatrical. To the animal, it is survival, an instant brilliant distraction in a world where every second counts. Communication is another key role. Some fish flash in rhythmic patterns signaling to others of their kind. In the darkness, where sight is limited, a specific sequence of blinks might be the only way to find a mate. In fact, researchers suspect that entire species may be distinguished by their bioluminescent signatures, with each producing a unique pattern that acts like a personal name. To us it is a mystery, a silent Morse code drifting through the abyss. To them, it is language, precise and necessary. Jellyfish offer some of the most spectacular displays. Many species glow when disturbed, lighting up in rippling pulses that travel across their gelatinous bodies. Some can produce spirals, rings, or expanding waves of light that make them look far larger than they are. Predators startled by the sudden glow may hesitate, giving the jelly time to drift away. Others may be drawn to the light only to encounter stinging tentacles instead of prey. Even fragile-looking creatures, transparent and delicate, carry these luminous defences. Not all light is visible to us. Some deep-sea animals produce bioluminescence in wavelengths humans cannot detect, particularly in the ultraviolet or far-red spectrum. Other creatures have eyes tuned specifically to these invisible glows, allowing them to communicate in ways hidden from predators. It is a kind of secret channel, a private language in the dark where only those with the right eyes can see the message. The mechanisms behind bioluminescence are as fascinating as the displays themselves. In most cases, light is produced by a chemical reaction involving luciferin, a compound that emits photons when oxidized, and luciferase, an enzyme that catalyzes the process. Some animals manufacture these compounds on their own, while others acquire them from symbiotic bacteria. In fact, in many species, the light-producing organ is essentially a chamber filled with bacteria that glow continuously. The animal provides shelter and nutrients, and the bacteria provide light. This partnership is one of the most successful alliances in the deep sea, showing how even microscopic life shapes survival strategies in the abyss. If you imagine drifting through the water here, surrounded by these lights, it would not feel like the total void you might expect. Instead, it would feel alive with quiet signals, each glow a message, a trap, or a defense. A lanternfish might flash briefly before vanishing into the dark. A squid might pulse steadily, painting itself in a soft outline. A jelly might ripple with light, trailing sparks like a comet. To us, it would look beautiful, hypnotic even. To the creatures involved, every glow has meaning. And beauty is not the point here, but efficiency. In a world without sunlight, creating light costs energy. Every photon is an investment. Animals cannot afford to waste it, so the strategies they use are fine-tuned, evolved over millions of years to make the most of every glow. A flash too bright might attract predators as well as mates. A lure too faint might fail to attract prey. Balancing these trade-offs is survival itself. Humans have only begun to understand the complexity of this luminous language. When researchers send cameras into the deep, they often discover new displays never seen before. A squid releasing bursts of light in spirals. A fish with glowing patterns that ripple like neon signs. A worm producing glowing threads that unravel behind it. Each discovery expands our sense of what bioluminescence can be, and yet we know we've only seen a fraction of it. The abyss is too vast, too unexplored, for us to claim we've catalogued its light shows completely. The existence of bioluminescence also has implications beyond biology. It raises questions about evolution itself. How many times independently has light evolved in the deep sea? The answer appears to be dozens, maybe even hundreds. Each lineage, from fish to shrimp to bacteria, developed its own form of it, shaped by its own needs. That convergence tells us something profound. In a world without sunlight, light is so valuable that life finds a way to reinvent it again and again. For humans, encountering these glowing creatures often feels like stepping into another planet. Many explorers describe the sight of bioluminescence outside their submersible as one of the most unforgettable experiences of their lives. It is not just the strangeness of it, but the realization that this is normal for the animals involved. What seems like a spectacle to us is simply the background of their existence. And yet, for all the wonder it inspires, bioluminescence is still about survival. A flash that looks beautiful to our eyes is, to a squid, the difference between life and death. A steady glow that seems like decoration is, to a fish, the only way to remain unseen. A lure that looks elegant is, in reality, a carefully tuned weapon. In the abyss, nothing is wasted, not even light. As we keep drifting downward, it becomes clear that glowing creatures are not the exception here, but the rule. In the absence of the sun, life has become its own source of illumination. The abyss is not a void of silence and shadow. It is a place where biology has created its own stars, moving constellations that speak, hunt, hide, and survive. And the more we observe them, the more we realize how strange and varied survival can be in this place. Ahead, beyond the glowing displays and luminous signals, lies another side of the story. Not every creature of the abyss dazzles with light. Many survive through different means, with shapes and strategies that strike us as strange, even unsettling. The abyss is filled not only with sparks of brightness, but with bodies shaped by pressures and conditions that make them look alien to us. These odd forms are just as much a part of survival in the deep as glowing lights, and they remind us that the abyssal world is a gallery of possibilities far beyond what we might expect. In the depths of the abyss, beyond the flickers of bioluminescent light, what stands out most is the sheer variety of shapes that life has taken. To us, raised in a world of familiar animals, these bodies look strange, even grotesque at times. Wide, gaping mouths, needle-like teeth, transparent skin, gelatinous forms, eyes either enormous or absent altogether. Some creatures seem like exaggerations, as if nature pushed their features too far. Others seem unfinished, lacking the solidity and symmetry we expect from living things. But here, in this cold, pressurized darkness, every detail is survival. The bodies may look bizarre to us, but to the abyss, they are logic made flesh. Take the gulper eel, for instance. Its body is long and thin, ending in a tail tipped with a small glowing lure. But its most striking feature is its jaw, a mouth so large it seems out of proportion with the rest of its body. When fully opened, the gulper eel's mouth is larger than its entire head and trunk, like a balloon stretched wide. It uses this to engulf prey far bigger than itself, a strategy that makes sense in a place where meals are unpredictable. It cannot afford to let anything edible slip away. A design that looks absurd on land is perfectly rational here. Or consider the anglerfish again, with its enormous teeth that curve inward like prison bars. To us, the mouth seems oversized, the teeth too sharp for such a small body. But the abyssal world is one of scarcity, and a predator that catches prey must make sure it cannot escape. Once a fish is inside those jaws, the angled teeth prevent any retreat. The stomach, elastic and expandable, can hold meals nearly twice the predator's size. To us it looks monstrous. To the anglerfish, it is efficiency incarnate. Other species show the opposite extreme. Some fish, like the snailfish, lack rigid skeletons altogether. Their bodies are soft, gelatinous, almost floppy, as though they were unfinished. But in the crushing pressure of the deep, rigidity can be a weakness. Bones might fracture, structures might collapse. Softness, paradoxically, is strength. A body that yields to pressure survives where a hard body would fail. These fish float effortlessly in the water, their flexibility allowing them to thrive in places where few others can. There are creatures whose bodies are nearly invisible, transparent skin revealing organs and muscles within. Glass squid, for example, have translucent bodies that make them hard to spot in the dark water. Only their eyes, sometimes enormous, give them away. Some jellyfish are so clear that they vanish completely when the lights of a submersible are turned off. Transparency, a feature that looks delicate to us, is one of the best defences in a world without landmarks. When light is scarce and predators are searching, the ability to simply disappear is more effective than armour. Other creatures adapt by becoming enormous in unexpected ways. Giant isopods, relatives of the small pillbugs found on land, grow to the size of dinner plates. Their armoured shells and slow movement seem unwieldy, but in the abyss, this bulk allows them to store energy and endure long stretches without food. They can go for years without eating, yet when a large carcass falls to the seafloor, they gorge themselves until their bodies swell, storing nutrients for the next long wait. Their size, strange as it looks, is a solution to famine. Many abyssal animals also feature eyes that defy our sense of proportion. The giant squid, for example, has eyes the size of basketballs, the largest in the animal kingdom. Such enormous eyes are not a mistake. They are tuned to detect the faintest glimmers of bioluminescence in the dark, as well as the silhouettes of distant predators like sperm whales. To us, the size looks excessive. To the squid, it is the difference between sensing danger and being caught. In other species, the opposite is true. Some fish in the abyssal plain have lost their eyes entirely, evolving in darkness where vision is pointless. Instead, they rely on vibrations, smell or touch, replacing sight with other senses that work more reliably in permanent night. The strangeness extends even further when you look at how these creatures feed. Some have jaws that can unhinge, opening wide enough to swallow prey whole. Others have needle-like teeth so thin they look more like pins than fangs, designed to trap plankton and small fish drifting in the water. Some worms extend long, sticky filaments into the current, catching whatever particles pass by. Others burrow into the sediment, filtering organic matter grain by grain. To us, these feeding strategies seem alien, but each is an elegant response to the abyss's central problem. Food is scarce, and you cannot afford to be picky about how you obtain it. Even reproduction shows unusual shapes and strategies. Some deep-sea species produce eggs that glow, bioluminescent orbs drifting through the water to attract mates or perhaps to distract predators. Others carry eggs within their bodies until the young are ready to emerge, ensuring survival in a place where scattering them freely would mean losing them to the void. Male anglerfish, as mentioned earlier, fuse with females, reducing themselves to little more than reproductive organs attached to a host. In other cases, males and females may release gametes into the water at the same time, relying on chance encounters in the vast dark. These strategies sound strange to us because they do not match the reproduction we know, but in a realm defined by distance and rarity, they are logical responses. Then there are the creatures that seem almost too fragile to exist. Delicate sea cucumbers float with balloon-like appendages, drifting on currents like jelly-filled bags. Feather stars extend fronds into the water, filtering food like a plant rooted to the seafloor, though they are animals. Giant siphonophores, colonial organisms related to jellyfish, can grow to lengths longer than a blue whale. They are not single animals, but colonies of specialised units working together as one, some for feeding, some for defence, some for reproduction. To us, such a body plan looks chaotic, but it is one of the deep sea's most successful strategies. Many of the strangest shapes are designed not for hunting or defence, but for simply existing in an environment where every detail matters. Flattened bodies reduce drag in slow currents. Elongated fins allow delicate control in still water. Strange appendages extend sensing abilities, feeling vibrations or detecting chemicals in ways we cannot imagine. Each detail is survival honed over millennia, shaped not by randomness, but by pressure, darkness, and scarcity. The abyss is a place where our sense of what is normal unravels. On land, we expect animals to follow certain rules. We expect symmetry, proportions that make sense, forms that look efficient to our eyes. But in the deep, those rules bend. Efficiency here is not about looking neat or balanced. It is about working within the abyss's unyielding conditions. What looks strange to us is not strange at all down here. It is simply correct. Even the behaviour of these animals can appear alien. Some drift nearly motionless for hours, conserving energy in a way that feels unnerving to watch. Others pulse or flicker with light in patterns that seem almost mechanical. Predators may lie in wait for days, unmoving until the right opportunity passes. Prey animals may spend their entire lives avoiding encounters, relying on camouflage and silence. The abyss is not a world of constant movement and activity like the surface oceans. It is a world of patience, stillness, and sudden bursts of action. And yet, despite all these adaptations, we have only seen fragments of what lives here. Every expedition into the abyss reveals new shapes we cannot explain immediately. A fish with tubular eyes that rotate like periscopes, a squid with arms ending in hooks instead of suckers, a jellyfish with internal lights arranged like a glowing galaxy. These forms remind us that the story of life in the abyss is still unfolding, and our catalogue is incomplete. If you were to sit quietly in a submersible on the abyssal plain, watching through the glass as the lights were dimmed, you might first see nothing. Then, slowly, shapes would begin to emerge. A translucent fish drifting by, its stomach glowing faintly with the bioluminescent prey it just consumed. A crab scuttling across the sediment, armoured and heavy. A sea cucumber inching forward, its body leaving faint marks in the mud. Each one is strange in its own way, but together they form a community that makes sense only here. The longer you stayed, the more normal these shapes would begin to feel. What looked bizarre at first would start to seem logical. You would begin to understand that survival does not care about our sense of beauty or design. It cares about what works. And in the abyss, what works often looks stranger than anything we can imagine. As we continue drifting through this world of unusual bodies and improbable survival strategies, it becomes clear that adaptation is not limited to feeding, defense, or shape. Survival in the abyss also depends on what happens when food finally reaches the seafloor, when the slow rain of marine snow gathers into something more substantial. Ahead, we begin to encounter the scavengers that define life on the bottom, creatures specialised in turning every scrap of falling matter into sustenance. The deeper we move into the abyss, the more we see how survival here depends on making use of whatever the ocean gives. Nowhere is that clearer than on the seafloor itself, where the rain of marine snow and the occasional fall of larger animals become the foundation of life. The creatures that live here are not hunters in the way we imagine predators on land or in the upper ocean. They are patient scavengers, specialised in finding, consuming and recycling the fragments that sink from above. To us, scavenging often carries a sense of desperation, of taking what is left over. But in the abyss, it is the primary strategy. It is not an afterthought, but the core of existence. Picture the abyssal plain, stretching out flat and featureless under kilometres of water. To the eye it looks barren, soft mud, fine sediments, little to mark distance or direction. But if you wait, you notice movement. Something stirs in the sediment. A pale worm emerges, writhing as it sifts particles. A small crustacean hops briefly before disappearing into the mud again. Further off, a sea cucumber, soft and bulbous, moves slowly across the seafloor, leaving a trail behind it. Nothing moves quickly here, but everything has purpose. Each shift, each crawl, each burrow is directed toward food, and the food is everywhere, scattered thinly in particles too small to see, but rich enough to sustain life when collected in large amounts. Sea cucumbers are among the most common animals here. Their bodies are elongated, soft, and often semi-transparent. They feed by swallowing mouthfuls of sediment, digesting the organic matter within, and expelling the cleaned grains behind them. To us, this might look monotonous, but it is the slow but steady rhythm that defines the abyss. Across vast plains, countless sea cucumbers plough through mud, each one recycling the sediment, turning it over in endless cycles. Without them, organic matter might build up unevenly. With them, the seafloor is constantly renewed, a living conveyor belt driven by patience. Alongside them move brittle stars, relatives of starfish with long, slender arms. They spread across the mud like living nets, catching particles and tiny organisms from the water. Some wave their arms upward, filtering food drifting by. Others crawl across the surface, scavenging fragments already settled. In large numbers they form carpets that can cover kilometres, each one moving independently but together creating a living layer of scavengers. When a larger piece of food arrives, like a fallen fish or squid, they gather quickly, swarming in numbers that can strip flesh in hours. Then there are the giant isopods, armoured crustaceans that look like oversized pill bugs. They are slow, lumbering creatures with segmented shells and powerful jaws. For most of the time, they move cautiously across the seafloor, searching for fragments. But when luck strikes and a larger carcass appears, they gorge themselves, sometimes eating so much that their bodies swell into immobility. This strategy is essential, because they may not encounter another large meal for months or even years. Their strange, bulky shape is not a mistake. It is a design built for feast and famine, for patience in the long wait and excess when fortune arrives. Scavenging here is not limited to animals visible to us. Much of the work is done by microbes, bacteria and archaea that break down organic matter at the molecular level. They are the recyclers of the abyss, decomposing the smallest fragments and releasing nutrients that larger organisms can then use. Without them, the system would collapse. With them, the abyss remains alive, its cycles maintained even when visible life seems scarce. These microbes are so well adapted to the deep that many cannot survive at the surface. The absence of pressure is lethal to them, just as the presence of it is to us. To the microbial scavengers, the abyss is not extreme, it is home. Every so often, the seafloor receives more than a drizzle of marine snow. Sometimes the ocean delivers something immense. When a whale dies, its body may drift downward for weeks before finally settling on the abyssal plain. When it does, the impact is transformative. A whale carcass can weigh tens of tons, carrying more energy than the surrounding ecosystem would normally see in decades. The moment it lands, scavengers converge. Hagfish burrow into its flesh, tearing through fat and muscle. Sharks arrive, biting away huge chunks. Crustaceans swarm the surface. Within months, most of the soft tissue is gone, but the whale is not finished giving. Its skeleton remains, rich in lipids, and over the years bacteria colonize the bones, breaking them down and releasing chemicals that support specialized communities. Entire species of worms and mollusks live only on whale falls, dependent on the rare but recurring rain of giants from above. For decades, a single whale can sustain hundreds of species, and when it's gone, its legacy remains in the generations of scavengers it sustained. Even smaller falls matter. Fish, squid and jellyfish that die near the surface eventually drift down, becoming concentrated patches of food for scavengers. In a realm where energy is scarce, nothing goes unused. Crabs pick at the remains, worms burrow into the soft tissue, microbes dissolve what cannot be consumed directly. The cycle continues until every trace is gone. To us it might look grim, but here it is the foundation of survival. Death above fuels life below. It is not only animals that fall. Wood, seeds, and leaves from land sometimes wash into rivers and drift out to sea, eventually sinking to the abyss. Even small fragments of trees can create localized ecosystems, as bacteria and fungi break them down, and animals feed on the microbes that flourish. In a world without plants, even a single log becomes a forest of sorts, sustaining life far beyond its own lifespan. This relentless recycling shows how little is wasted in the abyss. Every scrap of material is used. Every fragment becomes fuel for something. On land, ecosystems can afford waste. Leaves rot on the forest floor. Fruit falls uneaten, carcasses dry in the sun. In the abyss, scarcity forbids waste. Efficiency rules, and scavengers enforce it with absolute precision. The scavengers themselves show remarkable patience. A sea cucumber may spend its entire life crawling slowly, consuming sediment grain by grain. A giant isopod may lie nearly motionless for months, conserving energy until food arrives. Brittle stars may spread in vast numbers, each one feeding on whatever tiny particles pass within reach. These lives do not resemble the urgency of surface animals, but they are no less successful. They are tuned perfectly to the rhythms of the deep, and yet when abundance does appear, the response is immediate. Within hours of a large fall, the seafloor is transformed into a gathering. Creatures arrive from the surrounding plain, drawn by chemical signals released into the water. The sight becomes crowded, frantic in a way that is rare in the abyss. Then, just as quickly, it returns to stillness once the meal is gone. These moments of activity punctuate the long stretches of quiet, marking the cycle of feast and famine. If you think about it, these scavengers are not simply cleaning the seafloor. They're connecting the surface and the abyss, transforming energy from one world into survival for another. The phytoplankton that bloom in sunlight, the fish that feed on them, the whales that swim in shallower waters, all eventually leave traces that reach the depths. The scavengers are the ones who ensure that energy is not lost but transformed, carried forward into new lives. They are the custodians of the abyss, keeping its cycles unbroken. For humans, watching these scavengers can feel eerie. The sight of pale worms writhing through a carcass, of crabs tearing into soft tissue, of isopods swelling grotesquely with food, it is easy to see it as grotesque. But the longer you watch, the more you realize it is not grotesque at all. It is precise, efficient, and balanced. In this world, there is no luxury of waste, no margin for excess. Everything that falls becomes part of something else. It is not morbid, it is elegant. And so, as we linger here, watching the seafloor come alive with its quiet recyclers, we begin to see how survival in the abyss is not only about individual creatures, but about the system they form together. The scavengers, the microbes, the predators that occasionally wander through, they are all connected by the flow of material from above. Without one, the others could not persist. And ahead, as we keep drifting deeper into this system, we encounter not only scavengers but hunters, animals that do not wait for food to come to them, but move through the darkness in search of it. Their shapes, strategies, and patience reveal yet another way that survival can look in the abyss. Not every creature of the abyss is content to wait for food to drift down. Some are hunters, moving quietly through the black water in search of prey. These hunters are not like those we imagine in the open seas near the surface, sleek sharks racing after schools of fish, dolphins chasing with speed, or birds diving from the air. In the abyss, hunting cannot rely on speed or abundance. The energy to move quickly simply isn't available, and prey is too rare to waste effort on long pursuits. Instead, predators here have evolved to be patient, stealthy, and efficient. They are hunters of silence, masters of ambush, and specialists in making every strike count. One of the most famous of these predators is the anglerfish, drifting almost motionless in the abyss. Its glowing lure swinging in front of its mouth draws in unsuspecting prey. The fish does not chase, it waits. It expends no more energy than necessary, letting curiosity bring its meal close enough to be engulfed. The teeth, long and needle-like, ensure that once inside, prey cannot escape. This is the essence of hunting in the abyss: minimal effort, maximum result. For the anglerfish, patience is as important as teeth. The gulper eel is another example. With its enormous jaw, it does not need to stalk prey actively. Instead, It lies in wait, ready to swallow whatever drifts close. Its stomach is expandable, capable of holding meals that seem impossible for its slender frame. It does not know when the next opportunity will come, so it takes everything it can, no matter the size. Its shape, strange to us, is a strategy that turns rarity into advantage. Where food is scarce, gluttony becomes survival. Other hunters use light not as a lure, but as a weapon. Certain squid can flash bright bursts of bioluminescence to disorient their prey, stunning them long enough for capture. Some fish emit steady beams from organs under their eyes, sweeping the darkness like headlights to reveal small animals nearby. This active use of light is rare, because producing it costs energy, but for some species it is worth the trade-off. Light reveals what the darkness hides, and in a place without sunlight, controlling light means controlling the hunt. There are predators that use stealth instead of light. The dragonfish, for example, has a long, slender body and a mouth filled with sharp teeth that can fold inward when not in use. Its body is nearly invisible, and it often remains motionless until prey comes within striking distance. What makes it more remarkable is its ability to produce red bioluminescence, a wavelength invisible to most other creatures of the deep. With this secret light, the dragonfish can illuminate its prey without being seen, like carrying a flashlight no one else can detect. To us, it seems like a clever trick. To the dragonfish, it is an ancient adaptation, honed by countless generations. Some abyssal hunters are enormous, though they move rarely. The giant squid is perhaps the most famous, a creature long imagined in myth before it was ever seen alive. With arms that can stretch for meters and eyes the size of basketballs, it is built for sensing and capturing prey in the darkness. It does not chase endlessly, but rather uses sudden bursts of power, striking with speed when the chance arises. Its suckers are lined with teeth-like structures, ensuring a firm grip. Few animals can resist once ensnared, and yet, even the giant squid is hunted itself, locked in a predator-prey relationship with sperm whales that has shaped both species over millennia. The scars on whales' heads and the remains of squid in their stomachs are evidence of battles fought in silence, deep below. Hunting strategies in the abyss also extend to the seafloor. Some fish bury themselves in the sediment, their bodies hidden while only their eyes or lures remain visible. When smaller animals crawl too close, they strike upward with sudden speed. Crabs and other crustaceans prowl the mud slowly, using chemical cues to detect food, then pounce when they find it. Even worms can be predators, with jaws that snap shut on unsuspecting prey that wanders into their burrows. The pace may be slower than the frantic hunts we imagine at the surface, but the principle is the same: patience, timing, precision. Sound plays a role in this world too. While light is scarce, sound travels easily through water. Some predators use sensitive organs to detect vibrations from moving prey. The faint ripple of a fin, the shift of sediment as something crawls. These signals carry in the silence. For prey animals, the challenge is to move without drawing notice. For predators, the challenge is to interpret faint clues correctly. One mistake could mean wasted effort, and wasted effort is costly in the abyss. When you look at these hunters, what strikes you is not just their strangeness, but their efficiency. Every adaptation seems designed to minimize waste. Wide jaws mean fewer missed opportunities. Bioluminescence targets prey without requiring fast pursuit. Expandable stomachs ensure that nothing is lost no matter the size of the meal. Camouflage reduces unnecessary movement. In a world where prey may appear once in a week, these adaptations are not just useful, they are necessary. The silence of hunting here is striking. On land, predators often reveal themselves with noise, the roar of a lion, the splash of a crocodile, the chase of wolves. In the abyss, sound is risk. Silence is survival. Predators move slowly, strike suddenly, and return to stillness. If you were observing them from a submersible, you might not notice anything at all until it happened. One moment the water would look empty, the next a mouth would gape open, teeth glinting faintly in artificial light, and then the movement would be over. The prey gone, the predator still. The variety of these hunters shows how flexible evolution can be. Some use patience, others deception. Some rely on sudden bursts, others on constant drifting. Some produce light, others hide completely. What they all share is the ability to survive in a place where energy is scarce and every mistake is costly. Hunting here is not about speed or spectacle. It is about precision and silence. And yet, the hunters are not alone. They are part of a system that includes scavengers, microbes, drifting prey, and even the environment itself. Their role is essential, but it depends on the flow of food from above and the recycling of matter below. The abyss does not belong to hunters alone. It belongs to all who can survive its rules. Still, watching these predators, it is hard not to feel awe. Their shapes may seem alien, their methods unsettling, but they are proof of survival against odds that seem impossible to us. They remind us that life finds ways not only to exist but to thrive, even where darkness and cold dominate. As we keep moving through this realm, surrounded by hunters that strike without sound and prey that vanishes without warning, another truth of the abyss becomes clear. It is not only individual creatures that seem unusual here, but the very principles of survival: pressure, scarcity, darkness. These have reshaped biology in ways we're only beginning to understand. Ahead lies an exploration not of single animals, but of the broader patterns that make this environment work, the oddities of pressure and adaptation, the strange rules of life when every detail is influenced by forces beyond anything we experience on the surface. The deeper we sink into the abyss, the more it becomes clear that life here is not defined only by what it eats or how it moves. The very environment itself, the weight of water pressing from every direction, and the unchanging cold, has reshaped biology into forms that seem unfamiliar. These are not just small adjustments, like the seasonal changes that animals on land experience. They are fundamental rewrites of the rules of living, changes so profound that they feel odd to us. But in this environment they are normal. Pressure is the single most constant force in the abyss, and adaptation to it is not just important, it is unavoidable. At the surface, we live under the pressure of the atmosphere, a single bar that we barely notice. Divers descending even a few dozen meters feel their ears ache as water pushes inward. That is a tiny taste of what creatures in the deep endure. At 4,000 meters, the start of the abyssal zone, the pressure is more than 400 times greater than the surface. At 6,000 meters, where the abyss gives way to the Hydrothermal trenches, it climbs beyond 600 times. If we tried to descend unaided, our lungs would collapse instantly, our bodies crushed before we could take a second breath. Yet here, animals live not in spite of that weight, but because of it. One of the most unusual consequences of pressure is how it affects chemistry. The proteins in our cells are delicate machines, folding into specific shapes that allow them to perform tasks like digesting food or repairing DNA. Under intense pressure, these proteins would distort, bending into shapes that no longer work. For surface creatures, this would be catastrophic. For abyssal animals, the solution has been to evolve molecules that stabilize proteins. They are called piercelites, and they act like scaffolding, holding the proteins in their correct shapes even under crushing weight. Without them, metabolism would fail. With them, life continues. It is an invisible adjustment, but it is the difference between collapse and survival. Another oddity comes from body structure itself. Many animals of the abyss lack the air-filled spaces common in surface creatures. Our lungs, sinuses, and even the hollow cavities in our bones would implode under high pressure. Abyssal fish avoid this by being soft-bodied, with tissues that match the density of the water around them. Their muscles may look weak, their bones reduced or absent, but these are not flaws. They are adaptations that allow survival where rigidity would shatter. The snailfish is a perfect example. Found in some of the deepest trenches on Earth, it has a translucent, gelatinous body with no scales and fragile bones. To our eyes, it looks fragile, as though it could not endure anything. Yet in reality, it thrives at depths where no other vertebrate can survive. Pressure also changes how animals use energy. Moving quickly in this environment is costly, and most deep-sea creatures have metabolisms slowed by both pressure and cold. They grow slowly, reproduce infrequently, and live longer than similar species at the surface. Some invertebrates may live for centuries. Even fish in the abyss often reach ages far beyond those of their shallow water relatives. In a world where energy is scarce, slowness is a strategy, and patience is more valuable than speed. Oddities appear not only in biology but in appearance. Many deep-sea fish have eyes far larger than expected for their size, sensitive enough to detect the faintest traces of light. Others have no eyes at all, their sight useless in complete darkness. Some produce their own light in patterns that look alien, arranged across their bodies in glowing spots or stripes. These patterns are not decoration but communication, recognition, or deception. The odd shapes we see, jaws that unhinge, bodies that stretch like ribbons, teeth that point inward, are not accidents. They are logical responses to pressure, darkness, and scarcity. Even reproduction shows strange solutions to pressure. In many species, fertilization happens internally rather than externally, since releasing eggs and sperm into such a vast pressurized void would make successful encounters unlikely. In others, males fuse permanently with females, ensuring reproduction without needing repeated contact. To us, this looks bizarre, even parasitic, but in an environment where individuals may never cross paths again, it is survival. Adaptation here is not about elegance, it is about certainty. Pressure also changes behaviour. Many abyssal animals do not move constantly but drift slowly, conserving energy. They may lie still for days, waiting for prey to come close enough. When they do strike, it is sudden and decisive, a burst of movement followed by stillness again. This rhythm, quiet patience punctuated by brief action, is not laziness, but necessity. In a place where hunting requires energy, there is no room for mistakes. Another oddity of pressure is how it influences size. Some creatures like giant isopods are much larger than their shallow water relatives, a phenomenon known as deep-sea gigantism. The reasons are still debated. Some scientists believe that the cold slows metabolism, allowing animals to grow larger over long lifespans. Others suggest that scarcity of predators in the deep allows bulkier bodies to survive. Still others point to the efficiency of large size for storing energy. Whatever the reason, the abyss is full of giants, squid with arms stretching meters, amphipods the size of hands, worms longer than a person. At the same time, some species show the opposite adaptation, dwarfism, where scarcity of food favours smaller, more energy-efficient bodies. The abyss has room for both extremes, shaped by subtle balances of energy and survival. Oddities also emerge in how animals sense their world. Some fish have lateral lines that detect vibrations far more sensitively than surface species. Others use chemical cues, smelling the faint traces of organic matter drifting in the water. Some may even detect electrical fields, sensing the movements of nearby animals without needing sight. In an environment where pressure makes fast movement costly and light is absent, these senses become more valuable than vision or speed. Microbes provide another example of adaptation. Many abyssal bacteria cannot survive without high pressure. To bring them to the surface is to kill them, not because of temperature or lack of food, but because without crushing force their enzymes collapse. To them, the surface world is the hostile one. These organisms have been found in sediments miles below the seafloor, surviving on trace chemicals and reproducing at astonishingly slow rates. Some may divide only once every few centuries. Their lives are measured not in days or years, but in geologic time. For humans, these adaptations seem odd because they do not align with what we expect of life. We are used to animals that move with speed, grow quickly, reproduce often, and use light as their guide. The abyss reverses these expectations. Slowness is strength. Softness is survival. Light comes not from the sun but from within. Reproduction is rare but certain. To us these rules look like distortions. To the abyss, they are the foundation of existence. And still, for all we understand, many oddities remain unexplained. Why do some animals glow in patterns that seem to have no function? Why do others grow to enormous sizes while similar species remain small? Why do some choose to invest energy in building complex jaws or lures, while others rely on simplicity? The abyss keeps its secrets, revealing fragments, but never the whole. Every expedition raises as many questions as it answers. If you imagine yourself here, surrounded by these creatures, you might feel that you're walking through a hall of mirrors. Everything looks familiar but distorted. Fish with exaggerated jaws, crabs grown oversized, worms glowing faintly, microbes that cannot live without pressure. It is like nature has taken the rules we know and bent them, twisting them into shapes that only make sense here. At first it feels unsettling, but the longer you watch, the more sense it makes. You begin to see the logic behind each oddity, the quiet reasoning of survival. These adaptations remind us that life is not fragile but flexible. It bends to whatever conditions it encounters, reshaping itself again and again. The abyss, with its crushing pressure and constant cold, is not a place that forbids life, but one that demands creativity. The results may look strange to us, but they are proof that survival has many forms. And so, as we drift deeper still, past the hunters and scavengers, past the glowing signals and the patient shapes, we begin to notice another rhythm of life here. It is not just about adaptation to pressure or cold, but about the steady flow of energy from above. Every particle of organic matter that falls, every carcass that sinks, every fragment of marine snow fuels the deep. Ahead, we will explore what it means when food falls from the sky, and how this endless rain from the surface sustains the abyss across centuries. For all the adaptations, the odd shapes, the patience, and the silence, life in the abyss still comes down to a single truth. Food must arrive from above. There is no sunlight here, no plants or algae to capture energy directly. Everything living in this realm depends on material produced closer to the surface, drifting slowly downward in a constant rain of particles. To the creatures of the deep, it is as though food falls from the sky, not in showers of abundance, not in predictable harvests, but in thin drizzles of fragments, the leftovers of life lived elsewhere. This is the defining rhythm of the abyss, a supply line from worlds they will never see. Marine snow is what scientists call this slow descent of organic material. To the eye it looks like dust, flakes and tiny specks drifting through water, swirling gently in the currents. Each particle might be a dead plankton cell, a fragment of fecal matter, a scrap of tissue from some distant jellyfish, or the remains of countless microscopic organisms. Individually they are almost nothing, too small to matter, but together, falling across centuries, they are the fuel of the abyss. In a realm where survival depends on every calorie, these tiny flakes are treasure. Imagine sitting in a submersible with the lights dimmed. At first you might think the darkness is empty. But as your eyes adjust, you notice movement outside the window, small drifting dots reflecting in the faint glow. Turn on the floodlights, and the beam fills with floating specks like dust in a room illuminated by sunlight through a window. Except here, the dust is alive with meaning. Each particle is energy on a journey downward, food for scavengers, microbes, worms, fish, and everything else waiting below. It is not snow in the sense we know on land, which melts and vanishes quickly. This snow accumulates, layer upon layer, across the seafloor, shaping the chemistry of the abyss itself. For the animals here, the snow is not only food but a schedule. Sea cucumbers crawl continuously, sifting the sediment for whatever organic material has landed. Brittle stars wave their arms to catch particles before they settle. Small crustaceans hover in the water column, picking off fragments as they descend. Each creature has a strategy, a way of intercepting or recycling the fall. There is no waste, no neglect, because nothing can be spared. Even microbes, invisible to the eye, thrive on the smallest bits, breaking them down into nutrients that others can use. But marine snow is not evenly distributed. In some places, upwelling currents bring nutrients to the surface, fueling blooms of plankton. When these blooms die, enormous amounts of material sink, creating temporary surges of food in the depths. In other areas, where surface waters are less productive, the fall is thin, leaving the abyssal plains nearly barren. The animals there must survive on far less, moving slowly, conserving energy, and waiting long stretches between meals. Geography, currents, and seasons above shape the fate of life kilometers below. The surface may seem unrelated to the abyss, but every storm, every current shift, every plankton bloom echoes downward, its effects felt far away in the silent dark. Every so often, the fall is more dramatic. A carcass sinks, a fish, a squid, sometimes even a whale. To the abyss, this is not just food, it is transformation. A whale fall, in particular, is like a banquet in a desert. When a whale dies and its body drifts to the seafloor, it delivers tens of tons of organic matter at once. Scavengers arrive first, hagfish burrowing into flesh, sharks biting chunks away, crabs swarming over the surface. Within months, the soft tissue is stripped clean. Then other creatures arrive, ones specialised in the next stage. Worms burrow into the bones, microbes colonise the lipids, clams and mussels flourish in the chemical-rich environment. What was once a single body becomes an entire ecosystem, lasting for decades. A whale fall is not an accident in the abyss. It is a pillar of life, rare but essential, one of the few ways that abundance ever reaches these depths. The importance of whale falls is difficult to overstate. They support entire communities of organisms that might not survive otherwise. Some species exist almost entirely in connection with them, found nowhere else. For decades, scientists did not realize how significant they were. It was only when deep-sea exploration revealed intact carcasses on the seafloor that the scope became clear. A single whale may feed hundreds of species across generations, bridging the gap between surface abundance and abyssal scarcity. Without them, the deep would be poorer, emptier, perhaps incapable of sustaining the diversity we now see. It is not only whales, large fish, turtles, even wood washed from land can sink into the abyss and spark bursts of activity. A single tree trunk drifting out from a river and finally falling to the seafloor can become an island of life. Specialized fungi and bacteria break it down, while invertebrates gather to feed on them. Even seeds or leaves, small as they are, add to the slow accumulation of organic matter. The abyss does not choose what falls, it accepts everything. Whatever descends becomes part of the cycle, whether it is a fragment of plankton or the body of a giant. The rhythm of this fall shapes everything. Animals do not eat when they want but when food arrives. They grow slowly because meals are unpredictable. They reproduce cautiously because energy must be saved. Even their bodies, with wide jaws and expandable stomachs, are designed to take advantage of rare opportunities. Some species gorge until they can barely move, surviving on a stored energy for months afterward. Others drift slowly, conserving energy until the next fragment falls. The economy of the abyss is ruled by patience and timing, not abundance. There is something humbling in realizing that the largest ecosystem on Earth depends on the leftovers of others. The surface world thrives on the sun, on constant cycles of growth and renewal. The abyss survives on what drifts downward, on fragments and remains. But this does not make it lesser. If anything, it reveals the interconnectedness of life. The plankton bloom in the sunlight becomes sediment in the dark. The whale swimming near the surface becomes a forest of worms and microbes at the bottom. Life in one realm sustains life in another, even when they never meet. And the fall is not only biological. Dust from deserts, soot from fires, even traces of human activity all eventually sink. Microplastics too now drift into the abyss, joining the snow. The deep is not isolated from the world above. It is its archive, collecting whatever the surface releases. In the sediment of the abyss, one can find a timeline of the planet, volcanic ash, pollen, pollution, remains of species long gone. Each layer tells a story of what once lived above. For the creatures here, though, it is simpler. They do not see the snow as history, but as sustenance. Every flake matters, every carcass transforms, every fragment is used. To us, it looks like scavenging, like dependence. To them, it is simply survival, efficient and unbroken. Imagine drifting with the snow yourself. A particle falling slowly through kilometers of water. On the way down, you might be intercepted by a lanternfish or eaten by a drifting shrimp. If you make it further, you might be consumed by a midwater jelly, or dissolve into nutrients that microbes use. If you reach the seafloor, you might become part of sediment sifted by a sea cucumber, or part of a feast for crabs gathered at a whale fall. Whatever happens, you're not wasted. In the abyss, nothing is wasted. This endless rain from above defines the deep. It is not steady in the way we measure time. It comes in pulses, in drifts, in occasional windfalls. But across the centuries, it is constant enough to sustain the largest ecosystem on the planet. The abyss endures because the surface gives, even without realizing it. And life here, in turn, closes the cycle, recycling what falls and making it part of something new. As we continue moving through this world, following the fall of food and the lives it sustains, another pattern emerges. Not all food comes from above. Some of it is generated here, in special places where heat from the earth itself fuels entire ecosystems. These are the hydrothermal vents, the strange cities of the deep, where survival is not a matter of waiting but of building life around chemistry itself. Not everything in the abyss depends on the slow rain of food from above. Scattered across the sea floor are places so unexpected, so alive, that they feel like a contradiction to the silence around them. These are the hydrothermal vents, fissures in the Earth's crust where seawater seeps down, heats in contact with magma, and then bursts back upward loaded with minerals. In the freezing dark of the abyss, these vents are places of heat, energy, and astonishing life. They are sometimes called black smokers or white smokers, depending on the minerals they release, and to stumble across one is to see a city of organisms thriving in a landscape that otherwise feels empty. The water that gushes from vents is not just hot. It can be hotter than boiling, reaching temperatures of 350 degrees Celsius or more. The immense pressure of the deep prevents it from turning into steam, so it pours into the ocean as liquid, dense with chemicals like hydrogen sulfide and methane. To most surface organisms, these compounds are toxic, but here they are fuel. Microbes use them in place of sunlight, performing chemosynthesis, transforming inorganic chemicals into energy, just as plants transform sunlight into sugars. These microbes are the base of an entire food web, supporting animals that have never seen light, never relied on marine snow, never depended on the sun at all. The communities that gather around vents are astonishing in their density. In contrast to the sparse, patient life of the abyssal plains, vents are crowded, bustling, almost chaotic. Tube worms cluster in masses, their red plumes waving in the chemical-rich water. Each worm can grow over 2 meters long, and they have no mouths or digestive systems. Instead, they house symbiotic bacteria within their bodies, which convert vent chemicals into nutrients. The worm provides shelter and access to chemicals, and the bacteria provide food. It is a partnership so complete that the worm has abandoned feeding entirely, trusting its internal partners to sustain it. Clams and mussels gather nearby, their shells thick and heavy. Like the tube worms, they often rely on internal bacteria, feeding not by filtering particles from the water, but by absorbing nutrients produced by their microbial partners. Crabs and shrimp swarm across the rocks, feeding on the bacteria directly or on the detritus of other animals. Fish lurk around the edges, picking off the smaller creatures. Even giant predators like deep-sea eels patrol the perimeter. For an environment that receives no sunlight, the abundance is staggering. A single vent field can support thousands of individuals packed together in a space no larger than a city block. What makes these cities remarkable is not just their density, but their independence from the surface. For centuries, scientists assumed that all life on Earth ultimately depended on the sun. Even in the abyss, the assumption was that marine snow, drifting down from photosynthetic organisms above, was the only possible energy source. Hydrothermal vents shattered that assumption. Here was an ecosystem with no reliance on sunlight whatsoever. Its foundation was geology and chemistry, not photosynthesis. That discovery in the late 1970s transformed biology. It suggested that life is not limited to where the sun shines. If entire ecosystems can thrive on chemicals at the bottom of the ocean, then perhaps life elsewhere in the universe could thrive in similar conditions, under the ice of Europa, for example, where a subsurface ocean may be in contact with volcanic activity. The vents of the abyss are not just biological wonders. They are windows into what life can mean on any world. The structures around the vents themselves are striking. As mineral-rich water pours out and cools, it precipitates compounds that build chimneys and towers, sometimes several meters tall. These structures grow, collapse, and rebuild over time, changing the architecture of the vent field. Black smokers release dark plumes dense with iron and sulfur, staining the water with a smoky appearance. White smokers release lighter minerals like barium and calcium, creating pale clouds. Together, they sculpt a landscape that looks alien, more like the surface of another planet than the floor of our own oceans. Life at these vents is not permanent. They are unstable, shifting with the movements of the Earth's crust. A vent that thrives for decades may suddenly collapse or go dormant, extinguishing the community it supported. When that happens, the animals must either die or disperse to find new vents. Some species are highly mobile, able to travel across kilometers in search of new habitats. Others rely on drifting larvae that may settle in distant vent fields. The result is a network of ecosystems scattered across the globe, connected by the migration of species over vast distances. For creatures that never see sunlight, the vents are oases, islands in a desert of darkness, and survival depends on moving between them as they appear and vanish. Among the strangest residents of these vents are the Yeti crabs. First discovered in the early 2000s, they are named for their hairy claws, which are covered in bristles. These bristles are not for fighting or decoration. They are home to bacteria, which the crabs cultivate deliberately. By waving their claws in the mineral-rich water, the crabs encourage bacterial growth, and then they scrape the bacteria off to eat. In effect, the Yeti crab farms its own food, tending to its claws as though they were fields. In the abyss, where creativity is survival, farming bacteria on your own body is not strange but ingenious. Shrimp at some vent fields show similar partnerships. Some species have light-sensitive organs on their backs, possibly adapted to detect the faint glow of hot vent water. They cluster so densely that the rocks seem carpeted with moving bodies, all feeding on the microbes or grazing on each other's growth. Their sheer numbers demonstrate how productive these ecosystems can be, fueled by chemical energy instead of sunlight. Even predators here have adapted in unexpected ways. Some fish around vents have highly specialized jaws, designed to snap up crabs or shrimp in the crowded fields. Others linger on the outskirts, taking advantage of the abundance without exposing themselves to the extremes of heat and chemistry near the vents themselves. Every niche is filled, every strategy explored. What is most striking, though, is the contrast between the vents and the surrounding abyss. Just a few meters away, the seafloor may be empty, sparsely populated by slow scavengers. At the vent, life bursts into density, colour and motion. Red plumes of tube worms, pale shells of clams, swarms of shrimp, clouds of microbes, all crowded together in a place that should not exist by surface logic. The boundary is sharp, a line between scarcity and abundance, silence and bustle. It is as though two different planets share the same space, separated only by the reach of chemical plumes. Scientists studying these communities often describe them as cities, not because the animals build structures, but because of the density, specialization, and interdependence. Tube worms provide foundation, clams and mussels add layers, shrimp and crabs move like citizens, predators patrol like guards. Microbes are the architects, shaping the entire system from the smallest level. It is a city built not of stone or steel, but of partnerships, fueled by chemistry rising from the Earth's interior. These cities remind us that life is not bound to a single pattern. Sunlight is not the only source of energy. Plants are not the only foundation for ecosystems. The rules we take for granted on the surface are not universal. Life rewrites them wherever it must. In the abyss, at the edges of tectonic plates, amid water hot enough to kill us instantly, entire communities flourish. And still, for all the abundance here, these cities are fragile. A vent can shut down without warning, and when it does, everything changes. The tube worms die, the bacteria vanish, the crabs and shrimp disperse. The city collapses, its residents forced to move on or perish. New vents form elsewhere, and life begins again, but the memory of the old city lingers in the shells, tubes and mineral towers left behind. In this way, the abyss builds and erases its own landscapes, shaping a cycle of creation and destruction that continues unseen. If you were to stand in a submersible near a vent, you would see not just animals, but motion everywhere. Clouds of microbes swirling in the plume, shrimp crawling over each other, tube worms swaying in the current, crabs clambering across shells. The heat would distort the water, shimmering like waves of air over desert sand. The chimneys would rise like towers, exhaling smoke into the darkness. It would feel like a city alive with purpose, yet built on a foundation utterly different from our own. And as we leave these vent fields behind, the contrast becomes sharper still. Outside their plumes, the abyss returns to silence and cold. Life continues, but at the slower pace of scavengers and drifters. The cities fade into the distance, rare and scattered but unforgettable. Ahead, as we drift further, the creatures we encounter are not clustered in communities but spread across emptiness. They are larger, stranger, sometimes legendary in scale, ghostly giants that remind us how much of the abyss remains hidden from us. There is something about the abyss that invites the imagination to conjure shapes larger than life. For as long as humans have sailed the oceans, the idea of giants lurking in the depths has haunted our stories. Sailors once spoke of sea serpents longer than ships, of krakens pulling men into the water, of ghostly creatures rising from below to capsize boats. For centuries, these were myths, warnings traded around campfires or whispered on decks at night. But in the abyss, myths and reality often blur. Some of the creatures we once thought impossible are real, and others may still be waiting, undiscovered in the darkness where no light reaches. The most famous of these giants is the giant squid, a creature that for generations was little more than rumour. Sailors told stories of enormous arms rising from the water, of battles with whales that ended in blood-stained seas. For years, no one could prove whether the squid was real, until carcasses began washing ashore, their bodies mangled but their size undeniable. Eventually scientists confirmed what stories had suggested all along. A squid capable of growing more than 12 meters long, with eyes the size of dinner plates, living in the depths of the ocean. And yet, even with confirmation, the giant squid remains elusive. Very few have ever been seen alive. The first video recordings came only in the 21st century, showing a creature not monstrous but graceful, moving with quiet precision in the black water. It is not a predator of ships, but a hunter of fish and smaller squid, armed with tentacles lined with suction cups bearing serrated rings. Its massive eyes detect faint glimmers of light, its long body propels it in sudden bursts, and its size makes it one of the true giants of the abyss. Still, it is dwarfed by its even larger cousin, the colossal squid, which can reach lengths over 14 meters and has hooks on its tentacles instead of simple suckers. Where these creatures live, how they hunt, and how often they encounter sperm whales remains mostly a mystery. But the scars on whales, the remains in their stomachs, and the rare glimpses from submersibles tell us enough to know the legends had roots in truth. Beyond squid, the abyss holds other giants, though many are less famous. Deep-sea amphipods, small crustaceans related to shrimp, are usually only a centimetre long near the surface. In the abyss, they can grow to lengths of 30 centimetres or more, their bodies elongated by the strange conditions of deep-sea gigantism. Sea spiders, spindly arthropods, can reach sizes that dwarf their shallow water relatives. Even worms, simple as they seem, can stretch meters in length across the sediments of the abyssal plain. Then there are the creatures that remain ghostly, not only in form but in presence. The oarfish, for example, is the longest bony fish known, capable of reaching lengths over 11 meters. With a thin ribbon-like body and a bright red dorsal fin running the length of its frame, it drifts vertically in the water, moving slowly through the mid-water zone. Rarely seen alive, it has been the source of many sea serpent myths. When washed ashore by storms, its serpentine body seemed otherworldly, a literal ghost from the deep. To this day, encounters are so rare that every sighting is news, reinforcing its status as a legend. Other ghostly figures are less about size and more about appearance. Many deep-sea creatures are translucent, their bodies nearly invisible except for faint organs or glowing spots. Some jellyfish look like drifting globes of glass. Some siphonophores, colonial organisms, extend for tens of meters so long that they rival whales in length, yet so fragile they shatter at the slightest touch. One siphonophore filmed off Australia measured over 40 meters, coiled in a spiral in the dark water. It was not a single animal, but a colony, each part specialized for feeding, movement, or defense. To us, it looks like an alien, a ghostly spiral of living light. To the abyss, it is simply another way to be alive. Even sharks play a role in these legends. The Greenland shark, though not strictly abyssal, spends much of its life in deep, cold waters. It can live for centuries, perhaps more than 400 years, making it the longest-lived vertebrate known. Slow, enormous, and nearly blind, it drifts through the dark with patience unimaginable to us. To encounter such a shark is to meet not just a giant, but a creature whose lifespan stretches across human history, a ghost of time as much as of the sea. What fascinates us about these giants is not only their size, but their mystery. Despite centuries of exploration, we still know little about them. The abyss is vast, and even with modern technology, we have observed only tiny fractions of it. The possibility of undiscovered giants remains real. Some scientists speculate that large species of squid or fish may still exist, living beyond the reach of our submersibles and nets. The ocean is simply too big, too deep, for us to claim we've found everything. Myths may exaggerate, but they are rarely invented from nothing. Often, they are echoes of truth, shaped by fear and imagination. Legends also speak of ghosts in another sense, Not creatures of enormous size, but animals so rare and elusive that they might as well be spirits. The barrel-leaf fish, for example, with its transparent head and tubular eyes, was known for decades only from specimens damaged in nets. It was not until cameras recorded it alive that its bizarre design became clear, eyes swivelling upward within a dome of fluid to scan for faint glimmers of prey. Seeing it alive was like encountering a myth confirmed, a ghost turned real. The abyss encourages this kind of thinking because it hides so much. Unlike land, where ecosystems are visible, or even the surface ocean, where animals can be observed directly, the abyss resists our gaze. Most of what we know comes from fleeting glimpses, broken bodies brought up by nets, or images captured in rare expeditions. It is an environment that naturally breeds mystery, where every shape can become a legend, and every rare encounter feels like proof of something larger. For the animals themselves, of course, there is no mystery. Giants, ghosts, and legends are just life as it is lived in the abyss. A squid with massive eyes is simply a predator designed for its world. A siphonophore longer than a whale is just a colony growing as colonies do. An oarfish drifting for decades is simply following its own survival strategy. It is our perspective that makes them legendary, our distance from their world that turns them into myths. And yet, myths have value. They remind us that the unknown still exists. They remind us that the planet is not fully mapped, that there are places where imagination and reality blur. The abyss, more than any other environment, sustains that sense of possibility. For every giant squid confirmed, there may be another creature still unseen. For every ghostly fish filmed, there may be others drifting unnoticed. For every siphonophore captured in a spiral of light, there may be larger, stranger forms waiting beyond our cameras. As we drift further into this realm of giants and ghosts, the sense of mystery deepens. The abyss is not only about biology or geology, it is about imagination, about how humans have always looked at the ocean and seen both danger and wonder. These legends connect us to the people who first sailed the seas, who told stories of krakens and leviathans. Today we have science, cameras and submersibles, but the feeling is the same. When we see a giant squid, we are not just observing an animal, we're witnessing the echo of a legend, alive and real. And the deeper we go, the more we realise that these legends are only one way of understanding the abyss. For millennia, humans have placed the unknown ocean into myths, giving names and shapes to what they could not see. These myths may have changed over time, but they are still with us. The abyss is not only a place of giants and ghosts, it is a place of imagination, where human cultures have projected their fears and hopes. Ahead, as we continue this descent, we step into that history, exploring how the abyss has lived not only in nature, but in human myth and memory. Long before anyone sent machines to the deep or captured footage of glowing fish, the abyss existed in human thought as a place of imagination. People have always looked out at the ocean and wondered what lay beneath. Standing at the edge of the shore, watching waves roll endlessly into the horizon, it is natural to see it as vast, bottomless, mysterious. With no way to descend safely and no light reaching into the depths, the unknown became fertile ground for stories. Myths were born not from what people saw, but from what they could not see. In many cultures, the ocean was not simply water, but chaos, an unformed void. Ancient Greek thinkers spoke of the abyss as a place without bottom, a yawning chasm from which creation itself might emerge. In Mesopotamian mythology, the goddess Tiamat embodied the primeval sea, chaotic and terrifying, her waters giving rise to the world but also threatening to consume it. The ocean was a paradox, both the source of life and the symbol of danger. In this way, the abyss was never just a physical depth, it was an idea, a way to explain the immensity of existence itself. Sailors across the ages filled this idea with creatures. Sea serpents slithered through the depths in Norse legends, enormous enough to circle the world. In Japanese folklore, Dragons lived beneath the sea, their palaces built of coral and pearl, ruling the underwater realm. Polynesian myth spoke of beings that dwelled in the deep, testing or guiding those who crossed the ocean. In each case, the abyss was imagined not as empty, but as inhabited, populated with beings larger, stranger, and more powerful than anything known on land. The darkness below was not lifeless, it was overflowing with possibility. Even in medieval Europe, maps marked the edges of the known world with warnings. Here be monsters, the cartographers wrote, leaving open space for what no one had yet charted. To sail into waters far from land was to risk encountering the unknown, and the abyss was always part of that unknown. Tentacled beasts, colossal whales, serpents with eyes like lanterns, all found their way into drawings and tales. Sailors returned with stories of creatures glimpsed at the edge of vision, shapes breaking the surface before vanishing again. Whether real or imagined, these stories carried weight. They shaped how people thought about the sea, and through it, about the world. The persistence of these myths shows something about human nature. Faced with the unseen, we fill it with images drawn from our fears and hopes. Darkness becomes danger. Vastness becomes inhabited. The unknown becomes alive. In this way, the abyss was never truly empty to human imagination. It was full, a canvas for our deepest emotions. When science began to explore the deep, these myths did not vanish. They transformed. The giant squid, once a kraken of legend, became a real animal. Still mysterious, but now understood in biological terms. The oarfish, once a sea serpent, became a fish with a ribbon-like body. Even the monstrous leviathan described in biblical texts found echoes in whales, creatures real enough to sink ships when threatened. The abyss, explored with nets and submersibles, revealed that the myths were not inventions, but distortions, stories stretched from fragments of truth. But the myths also persist because the abyss is still, to a large extent, unknown. Even today, with all our technology, we have mapped only small portions of the seafloor in detail. The vast plains, trenches and mountains below remain hidden. New species are discovered on nearly every expedition. Strange shapes drift past cameras. Unfamiliar lights flicker in the darkness, and the imagination continues to reach beyond what is proven. For every myth resolved, another emerges, fueled by the enormity of what remains unseen. The abyss also enters imagination in subtler ways. Writers and artists use it as metaphor. The unknown, the subconscious, the place of fear or possibility. To speak of staring into the abyss is to speak of confronting the limits of what we can know, or of facing something vast and incomprehensible. The ocean's depth becomes a symbol for the depth within ourselves, both creative and unsettling. In this way, the abyss is not just a place in the world, it is a mirror reflecting back our own uncertainties and questions. Stories of the abyss are not only about monsters, they are also about beauty. In some cultures, the deep was imagined as a place of wonder, with palaces of coral, jewelled fish, and treasures hidden in darkness. The idea of mermaids, half human, half fish, spoke not only of danger, but of allure, the sea as both threatening and enchanting. Legends of sunken cities, from Atlantis to Lyonesse, placed human grandeur beneath the waves, turning the abyss into a keeper of secrets. To imagine the deep was to imagine both terror and fascination, destruction and beauty together. Modern culture has continued this tradition. Films, books and stories return again and again to the ocean depths as a place of mystery. Sometimes it is horror, the lurking monster, the hidden danger. Sometimes it is adventure, the quest to explore, to uncover treasures or civilizations. And sometimes it is science fiction, imagining life in alien oceans far from Earth, drawing directly from what we see in hydrothermal vents and abyssal plains. In every case, the abyss provides the setting because it is the closest thing on our planet to another world. Even science itself has been shaped by this imagination. The discovery of hydrothermal vents, of bioluminescent creatures, of giant squids, all carry with them a sense of wonder that echoes myth. When explorers describe seeing glowing fish drifting past their submersible windows, they often compare it to looking at a night sky filled with stars. The language of myth remains because the experience still feels beyond ordinary understanding. The abyss inspires not only curiosity but awe, the same awe that once gave rise to stories of krakens and sea serpents. It is important to see that myths are not mistakes, they are responses. When faced with something vast and unseen, people sought meaning, they gave it shape, and often those shapes pointed in the right direction. They sensed that the ocean was not empty, they sensed that it held giants, strange lights, and endless mysteries. Today we know more, but the essence is unchanged. The abyss is still a place where our imagination thrives, where the boundary between fact and story blurs. If you were to sit on the deck of a ship at night, staring out into the black water, you might feel the same thing sailors once felt. The ocean would seem endless, silent, and impenetrable. You might imagine what moves below, what unseen shapes drift in the dark. Even knowing the science, even understanding the biology, the feeling remains. The abyss is more than a physical place. It is an idea, a presence that pulls our thoughts into realms both fearful and creative. As we drift deeper into this journey, we carry those myths with us. The abyss is not only inhabited by fish and worms, not only shaped by pressure and cold, it is also inhabited by our stories, by the dragons and serpents we once placed there, by the symbols of chaos and beauty that cultures across the world have imagined. And even as we replace myths with knowledge, the feeling does not vanish. It transforms into the same awe we feel when we see a glowing squid or a colony of tube worms at a vent. The abyss continues to be both real and imagined, both biological and symbolic. And ahead, we step from imagination back into reality, into the ways humans have begun to reach into the abyss not through stories, but through technology. Submersibles, remotely operated vehicles, deep diving cameras, our tools have finally allowed us to visit the place we once only imagined. What was myth has become exploration, and what was once fear has become curiosity. The abyss is no longer just a canvas for imagination. It is now a frontier of discovery. For most of human history, the abyss was beyond reach. People sailed over it, told stories about it, feared it, and wondered about it, but they had no way to see what was truly there. Nets lowered from ships could catch fish or strange creatures, but whatever came up was usually crushed, distorted, or dead from the pressure difference. For centuries, the deep was known only by fragments, glimpses, and imagination. Only in the last 100 years have we found ways to visit it directly, to peer into its depths, and to witness the life that has always existed out of sight. The first attempts were simple but ambitious. Weighted lines dropped from ships to measure depth. Sailors in the 19th century used this method to map parts of the seafloor, lowering ropes that sometimes stretched miles. The results were rough, but they revealed something important. The ocean was deeper than anyone had expected. Trenches, ridges, and plains existed far below, unseen and unmapped. The idea of a flat seabed vanished, replaced by a new sense of a complex landscape beneath the waves. Later came dredges and trawls, nets dragged along the bottom to bring up samples. These expeditions brought the first real evidence of life in the deep. In the late 1800s, the Challenger expedition circled the globe, collecting thousands of species, many from great depths. What they found shocked the scientific community. Life was not limited to shallow waters as many had assumed. Instead, the deep was rich with species no one had ever seen before. Strange fish with lantern-like organs, delicate starfish from abyssal plains, worms and corals from deep ridges. Each haul was a revelation. The deep was not empty, it was alive. But nets could only tell part of the story. Animals dragged from kilometres below were often damaged, their soft tissues collapsed, their bodies altered by the sudden drop in pressure. To truly understand the abyss, humans needed to see it as it was, alive and intact. That required going down, and that was a far greater challenge. The first people to descend into the deep did so in the 1930s. William Beebe and Otis Barton built the bathysphere, a steel sphere lowered on a cable from a ship. Through small, thick windows, Beebe described creatures never before seen. Glowing fish, jellyfish with pulsing lights, and strange forms drifting in the dark. His words remained some of the earliest eyewitness accounts of the deep. The bathysphere could not travel far, it was tethered and limited, but it proved that humans could survive at depths that had once seemed impossible. The next great leap came with the invention of the bathyscarf, a self-propelled submersible designed to descend into the deepest trenches. In 1960, Jacques Piccard and Don Walsh piloted the Trieste into the Mariana Trench, reaching nearly 11,000 metres, the deepest place on Earth. Their journey took hours, the pressure outside their vessel immense, the descent through total darkness unnerving. At the bottom they saw life, a flatfish or perhaps a sea cucumber stirring on the sea floor. Even at that extreme depth, life persisted. Their dive showed the world that the abyss was not empty even at its greatest depths. Since then, exploration has advanced with new machines. Remotely operated vehicles, or ROVs, allow scientists to send cameras, arms and instruments into the deep without risking human lives. These robots can hover for hours, exploring trenches, vents and planes in detail. Manned submersibles still play a role, carrying scientists into the depths for first-hand observation. With each expedition, more is revealed. New species, new geological formations, new evidence of how life endures in the most extreme conditions. Deep-sea exploration is not easy. The pressure is immense, enough to crush steel. Temperatures near freezing make machinery brittle. Darkness means that powerful lights are needed, but those lights can disturb the very animals scientists want to observe. Communication with machines miles below the surface is slow, relying on cables or acoustic signals. Every dive is expensive, every expedition a major undertaking. Yet despite these challenges, we continue to explore, because the abyss remains one of the last frontiers on Earth. What makes exploration remarkable is not only the technology, but the surprises it brings. The discovery of hydrothermal vents in 1977, for example, came from an expedition that was meant to study geology. Instead, scientists found entire ecosystems thriving without sunlight, changing our understanding of life itself. Later dives revealed giant squid alive in their habitat, confirming myths that had lingered for centuries. Each new expedition seems to reveal something unexpected, something that reshapes our sense of what is possible. Exploration also extends beyond biology. Submersibles have mapped underwater mountains taller than Everest, trenches deeper than the height of the Himalayas, and volcanic eruptions hidden beneath kilometres of water. They have shown us tectonic boundaries, earthquake zones, and even chemical clues to the origins of life. The abyss is not only a biological mystery but a geological one, a place where the planet's inner forces meet the outer ocean. Still, for all our progress, the abyss remains largely unexplored. Estimates suggest that less than 20% of the seafloor has been mapped in detail. Most of the ocean is still hidden, its life unrecorded. For every species we have named, there may be dozens more waiting in darkness. For every vent or trench we have studied, there are hundreds still unseen. Even now in the 21st century, the abyss is more mysterious than the surface of the Moon or Mars. The question is not whether we will continue exploring, but how. New technologies are making it easier to map and study the deep. Autonomous vehicles can roam for weeks, collecting data without direct human control. High-resolution sonar can map terrain with precision never before possible. Advances in cameras and sensors allow us to see creatures alive in their habitat without disturbing them. Each improvement brings us closer to understanding the abyss, yet each also reveals how much remains unknown. Exploring the deep is not only a scientific pursuit, it is also a human one. The stories of the abyss, the myths and legends find echoes in the accounts of explorers today. Scientists describe the awe of descending into total darkness, of seeing glowing fish outside their windows, of drifting over landscapes no human has ever seen before. Their words are filled with the same wonder that filled myths of krakens and leviathans. The abyss inspires us not only with data but with feeling, with the sense of encountering something vast and beyond comprehension. If you imagine yourself in a submersible descending slowly, the experience becomes clear. The light from the surface fades until it is gone. The water grows colder, the pressure greater. Outside, faint sparks of bioluminescence drift past, silent companions in the dark. Hours later, the seafloor emerges in the floodlights. Strange creatures, volcanic chimneys, ridges and plains stretching beyond sight. It is another world, one that few have seen but that covers most of our planet. Exploration here is not like climbing a mountain or walking across a desert. It is entering a place that feels alien, even though it lies within our own world. And exploration does not end with seeing. It extends into understanding. Each sample brought up, each image recorded, each measurement taken adds to a picture of the abyss as an ecosystem connected to the rest of Earth. The currents that move heat, the microbes that recycle nutrients, the creatures that glow in the dark, all are pieces of a system that influences climate, weather, and even the habitability of the planet. Visiting the deep is not just about satisfying curiosity. It is about understanding our world as a whole. As we continue this journey, it becomes clear that exploration is not finished, and may never be. The abyss is too vast, too complex, too alive. Every discovery opens new questions. Every answer reveals more mysteries. For humans, that is part of the attraction. The abyss is one of the last places on Earth where the unknown still reigns. It challenges us, humbles us, and reminds us that no matter how advanced our tools, there are still places beyond our grasp. Ahead, as we drift from the story of exploration, we come to the reasons why this world matters to us at all. Beyond curiosity, beyond technology, there is a deeper connection. The abyss is not just a frontier to visit. It is a part of the planet's system, shaping climate, storing carbon, supporting life everywhere. To understand why it matters is to see the abyss not as separate from us, but as a force that sustains the world we live in every day. For most people, the abyss feels remote. It is far beneath the surface, hidden by darkness and pressure, a place that few will ever see directly. It can seem detached from our lives on land, as though it were another world entirely. Yet the abyss is not separate. It is part of Earth's system, and what happens here matters profoundly to life above. Even if we never descend into it, the abyss touches us every day, shaping climate, storing carbon, regulating the oceans, and reminding us of life's resilience in conditions we would call impossible. To see the abyss as distant is to miss its quiet influence. The first way the abyss matters is through circulation. The deep ocean is not still. Cold water sinks at the poles, dense with salt and oxygen, and begins a slow journey along the seafloor. This circulation, often called the global conveyor belt, moves water around the entire planet. It carries oxygen into the depths, allowing life to persist even kilometers below. It also stores heat, redistributing it between hemispheres, balancing climates across centuries. Without the abyss, weather on land would be very different. Storms, rainfall, even the growth of crops are influenced by patterns that begin with water sinking into darkness. The abyss is not just a place of life. It is an engine of the planet itself. The abyss is also a reservoir. Over millennia, it has absorbed carbon from the atmosphere, drawing it down into sediments and deep waters. When plankton at the surface die, some sink, carrying carbon with them. When whales and fish fall to the sea floor, their bodies become long-term storage of carbon in sediments. This process, often called the biological pump, is one of the most important regulators of Earth's climate. Without it, the atmosphere would hold far more carbon and the planet would be warmer. The abyss is not just a sink of pressure and cold, it is a sink of carbon, a balancing force that shapes the conditions for life on land. For scientists, the abyss matters as a record. Its sediments collect layers over time, storing information about the planet's history. Tiny shells of plankton settle, recording the chemistry of the ocean at the time they lived. Dust from deserts, ash from volcanoes, even traces of human industry all drift down and are preserved. To drill into these sediments is to read a history book written across millions of years. Ice cores tell us about climates of the past few 100,000 years. Deep-sea sediments stretch back much further, revealing patterns of extinction, warming, cooling, and recovery that shape our understanding of Earth's future. The abyss is not only a present ecosystem, it is a library of the planet's memory. The life within the abyss also matters in ways we are only beginning to understand. Many of the microbes here produce unique enzymes that function under high pressure and near freezing temperatures. These adaptations have potential uses in medicine, industry, and biotechnology. Enzymes from deep-sea bacteria are already used in DNA research, food processing, and detergents. Others may one day help us develop treatments for disease or methods for sustainable energy. The abyss holds a vast diversity of organisms we have barely sampled, each carrying biochemical solutions that could inspire human innovation. Beyond practical uses, the abyss matters as a frontier of possibility. The discovery of hydrothermal vent ecosystems thriving without sunlight expanded our understanding of where life can exist. It showed that energy for biology does not need to come from the sun. This has profound implications for the search for life beyond Earth. If bacteria and worms can live around vents on our seafloor, perhaps microbes can live beneath the ice of Europa or in the methane seas of Titan. The abyss is not just important for Earth. It is a model for the universe, a reminder that life is more adaptable than we once imagined. It also matters for culture. The abyss continues to inspire stories, myths, films, and art. Its darkness, its strangeness, its giants and ghosts all feed the human imagination. In a world where so much feels mapped and explained, the abyss remains a place of mystery, a space where curiosity can thrive. We need such places, not only for science, but for spirit. They remind us that the unknown still exists, that there are realms beyond our sight, waiting quietly. At the same time, the abyss is vulnerable. Human activity, once limited to the surface, now reaches into the deep. Plastic waste has been found in the Mariana Trench. Chemical pollutants accumulate in sediments. Fishing nets scrape across sea floors, damaging habitats that took centuries to form. Deep-sea mining, still in its early stages, threatens to disturb ecosystems we barely understand. The abyss has always seemed untouchable, but it is not. Its remoteness has protected it until now. Our technology is beginning to erase that distance. This raises an uncomfortable truth. The abyss matters not only because of what it gives, but because of what we risk losing. If we damage the conveyor of currents, we alter climate. If we disturb sediments, we release stored carbon. If we destroy habitats, we may lose species before we even know they exist. To protect the abyss is to protect our own future, even if we never see it with our eyes. Still, there is reason for hope. International agreements are beginning to recognize the deep sea as part of humanity's shared heritage. Conservation groups call for protection of vent fields, seamounts, and trenches before exploitation begins. Scientists argue for caution, for exploration before extraction, for understanding before disturbance. The abyss, once seen as empty, is now recognized as vital. The challenge is whether we act on that recognition. For individuals, the abyss may feel far away, but its importance filters into daily life. The climate we experience, the oxygen we breathe, the stability of ecosystems we depend on, all are influenced by the deep ocean. Even if we never sail, never dive, never look out over open water, the abyss matters. It shapes the world silently, invisibly, like a hidden foundation beneath a house. To forget it is to forget part of what sustains us. And perhaps most of all, the abyss matters because it is a reminder of humility. It shows us that the world is larger than our perception, more complex than our control, richer than our imagination. It challenges our assumptions, unsettles our expectations, and inspires our curiosity. The abyss does not need us, but we need it, not only for survival, but for perspective. It is proof that mystery endures, that life thrives in forms we would never predict, that the planet holds secrets still. As we drift onward, the reasons why the abyss matters settle around us. It is not only the carbon, the currents, the history, the life. It is also the awe, the imagination, the reminder of how small we are. From here it feels natural to move into reflection, to pause and consider what it means to live on a planet with such hidden depths. Ahead we find ourselves carried into closing thoughts, not as an ending, but as a drift alongside the abyss itself, a quiet acknowledgement of what it has shown us. The journey through the abyss leaves an impression that lingers long after the lights of the submersible fade. To spend time thinking about this realm is to recognize that it is not just a physical place, but a perspective, a way of seeing the planet differently. The deep ocean is the largest habitat on Earth, stretching across more than half the surface of the planet, yet it remains hidden. For most of us, it is something we know only by imagination, by fragments of footage, by the words of those few who have gone down. And yet, despite that distance, it influences our lives every day. To drift here in thought is to feel both far away and intimately connected, a paradox that mirrors the abyss itself. One of the strongest impressions from the deep is patience. Nothing here moves quickly. Food drifts down over weeks, years, centuries. Creatures wait silently for prey, conserving energy until the moment to strike. Communities form slowly around vents, flourishing while the chemistry is right, dispersing when the vent collapses. Even the great circulation of water that drives the abyss operates on timescales longer than human lifetimes, moving heat and oxygen over centuries. In a world where we measure time in minutes and hours, the abyss teaches us about time on a different scale, one that does not hurry. It is not frozen, but unhurried, a reminder that life does not always require speed. The second impression is resilience. Life in the abyss exists under pressures that would crush us instantly, in darkness where light has never entered, in cold that never rises above freezing. And yet, life thrives. It adapts in ways that seem strange to us. Soft bodies instead of hard skeletons, glowing organs instead of reliance on sunlight, partnerships with microbes instead of independent feeding. Each adaptation shows resilience, a flexibility that allows survival where we would expect none. The abyss reminds us that life is not fragile, it is inventive, persistent, unwilling to yield to conditions that appear impossible. There is also humility here. To explore the abyss is to realize how much of the planet remains unknown. Despite all our technology, our satellites, our maps, we have seen only fragments of the deep. New species are discovered on nearly every expedition. Entire ecosystems, like hydrothermal vents, were unknown to us until just decades ago. For every answer we find, more questions appear. The abyss humbles us by showing that the Earth is larger than our knowledge, that mystery still exists. In a time when so much feels explained, the deep remains unexplored, and that is a gift. For those who think of the abyss only as remote, there is a deeper connection to consider. Every breath we take is touched by it. The abyss stores carbon, moderates climate, circulates oxygen. It is not a separate world, but the foundation of the one we live in. Without its cycles, the atmosphere would change, the climate would shift, and life on land would be very different. It is easy to forget this because the abyss is invisible to us. But invisibility does not mean irrelevance. The most important processes are often the quietest. There is beauty in the abyss as well, though not always the beauty we expect. On the surface, beauty often comes from abundance, colourful reefs, bright flowers, flocks of birds. In the abyss, beauty is subtler. The slow drift of bioluminescent sparks, the pale outline of a translucent fish, the shimmering towers of vent chimneys, the ghostly forms of siphonophores uncoiling in the dark. It is a beauty born of adaptation, of survival, of contrast with the silence around it. To drift here is to learn to see beauty in patience, in strangeness, in forms that do not match our expectations. For humans, the abyss also offers perspective. We are used to thinking of the world as mapped, known, controllable. But the deep sea reminds us that most of our planet is still out of reach. It is vast, dark, unmapped, and full of life we have yet to meet. To accept this is to accept that mystery is not gone, that discovery is not finished. The abyss is a reminder that we live on a planet still capable of surprising us, still holding secrets beneath its surface. There is also a sense of continuity here. The abyss connects us to the earliest life on Earth. Microbes thriving in hydrothermal vents today may resemble the organisms that first appeared billions of years ago. Studying them gives us a glimpse of how life may have begun, of the conditions that made everything else possible. The abyss is not just a place of survival, it is a place of origins, a living link to the deep past of the planet. To drift here is to look backward in time as well as outward in space. It is not only history but future too. The adaptations we see here, life without sunlight, life under crushing pressure, life fed by chemistry instead of photosynthesis, suggest that the boundaries of biology are wider than we thought. This has implications beyond Earth. If life can exist here, it might exist elsewhere, in oceans beneath ice on distant moons, in chemical-rich seas on other planets. The abyss is not only part of our world, it is a model for other worlds, a reminder that life may be far more common in the universe than we once dared to imagine. As we linger with these thoughts, another impression emerges. The abyss does not end with our journey. It continues, quietly, endlessly, whether we observe it or not. Marine snow keeps drifting, creatures keep hunting, vent fields keep smoking, the global conveyor belt keeps circulating. The abyss does not wait for us, does not rely on our attention. It is independent, existing in its own rhythm, indifferent to our presence. That indifference is part of its beauty. It is a world that exists whether we see it or not, a reminder that not everything is made for us. And yet, despite that indifference, we are connected. Our actions affect the abyss, whether through carbon, pollution, or fishing. We shape it, even from a distance, and in turn, it shapes us. That mutual connection means we have responsibility. To forget the abyss is to forget part of ourselves. To protect it is to protect our own home. The abyss still matters, not only for its influence on the planet, but for what it teaches us about humility, patience, resilience, and mystery. If you were to imagine drifting here, in silence, watching faint glows pass by, it might feel endless. There would be no horizon, no landmarks, just darkness stretching forever. But in that darkness there is life, patient, resilient, creative. There is history, recorded in sediments. There is future, written in adaptations. There is mystery, waiting quietly. To drift with the deep is to accept that not everything is visible, that not everything is explained, that some truths exist only in silence. As this journey slows, it does not end. The abyss remains, stretching beneath the waves, shaping the world above, reminding us that Earth is more than the land we walk on. It is also the unseen, the hidden, the quiet deep. To think of it is to think of a world larger than ourselves, a world still alive with questions, still ready to surprise us. And as long as the abyss exists, so too will our curiosity, our awe, and our recognition that we are part of something vast.